Testing 1, 2, 3. There we go. We have audio. All right. So today we have ourselves a MacBook Pro 13-inch A1706 that is not turning on. Whenever the computer tries to boot up, it is introduced to a question mark, a folder with a question mark, which typically means that either A, the macOS operating system is not installed, or B, there's something actually damaged with the solid state. Now, I do already have some history on this unit where it's already been previously opened up before, and it looks like there is some damage on the board, specifically around the SSD controller. So in this case, we don't have to troubleshoot if this is a software issue. More than likely, this is going to be a hardware issue. So let's go ahead and kind of dive into the board and see what we're working with. Okay, so here's the computer right here, and I'm going to plug it into my USB ammeter and see what we are getting whenever we turn it on, as is. So right now we're pulling 20 amps at 0.8 amps, 20 volts at 0.8 amps. So that is proper powering on voltage and amperage. So we should see here in a second, I just heard the battery charging symbol. The backlight is turned on, but here in a second we should see a picture of a folder with a question mark. And that's going to be because it looks like there is some damage on the logic board, potentially around the SSD controller. So let's go ahead and just unplug our charger and kind of examine where that damage is at. That was actually an improper reading with the ammeter. We still have our battery plugged in. So whenever you're measuring or wanting to see how much amperage the computer is taking, you want to make sure that the battery is removed when you use your ammeter. That way, the battery itself isn't consuming any power from the charger to give it some charge. It's just going directly to the logic board so we can see exactly what it is powering on with. So we have 20 volts at 0.9 amps. So this is still booting voltage. We're getting all our power rails. It looks like this is going to be more of an SSD issue rather than a no power issue. I think some of the damage was actually around here on this side of the board. Now, the fascinating thing about this specific model is that the solid state is actually soldered on to the motherboard, meaning we can't just replace the solid state drives like we could in the older unibodies, like the A1278, A1286, I think A1297. Those were the unibodies. And then the MacBook Airs and MacBook Retinas from 2012 to 2015, you could simply just replace the solid state. Even the non-touch bar, the A1708, 2016 and 2017 MacBook Pro still had a removable SSD. It was a very funny looking model. There is no that proprietary Apple PCIe connection to USB adapter that you can buy that I'm aware of. Please correct me if I'm wrong. But it was something that you could remove in the event the SSD had failed. In this case, what Apple's decided to do is actually solder on the RAM underneath these little components that we see, or the cowlings is what Apple calls them, these heat shields, EMI shields. But the SSD is part of the logic board, which means if the SSD fails, the entire logic board has failed. So we either have to attempt to repair the SSD, or if the SSD or SSD controller is too damaged, unfortunately, this is going to be a board replacement. Let's look underneath with our microscope and see exactly where that damage is at. So I think I saw some over here, right there. So that component in particular is completely gone. Not only is it gone, there are traces that have been ripped. And what probably happened, if I had to guess, if you see right here, there's this little standoff, this stub. On previous models, you used to be able to unscrew the back of the computer. Let me put this back. Used to be able to unscrew the back of the computer with a total of 10 screws. You would have 4 up here at the top, 4 in the bottom, 2 in the side. For some reason, what Apple decided to do on this specific model is they put 4 in the top, 4 in the bottom, But instead of putting two on the side, they have two hooks, essentially, or two little like standoffs. So you actually have to use the suction cup to lift up the bottom case and then slide a pick underneath where the standoff's at in order to remove the bottom case. However, if you're not knowledgeable about the standoff, because this isn't really intuitive in my opinion, if you've never have opened up a MacBook before, it's very easy to kind of push something in there the wrong way and damage the component. And we can see, actually we don't even have to zoom in with the microscope, but where the damage traces are at, it's exactly right next to where that standoff, that hook that releases the bottom case is located. So let's see exactly what is that responsible for here on our logic board. So I've already went ahead and pulled up our Flexboard View software by Paul Daniels, and it looks like that component is U5860. Some sort. So it is going to talk to our SMC through a clock in data line. Let's see what else it's responsible for. Yeah, this is just going to be Thunderbolt thermal sensor, and we can kind of just make sense of that with the consonants that are here. If I had to assume Thunderbolt thermal sensor. And if this isn't present, I'm assuming the fan's going to run at high speeds, which I think is what happened when we first turned on the computer with just our charger. The fan started to rev up really high. But that doesn't really make sense as to why our SSD is still not working. We're still going to take care of this and repair it, but let's kind of examine the board for some further issues. And I can see there is a resistor that was ripped off in the same vicinity. So right next to where our damaged U5860 is, we have this capacitor that's completely gone. What is this capacitor responsible for? Here we are. This could definitely be why we're having an issue with our SSD. PP1V8 SSD cold. That is going to be a 1.8 volt line that is connected to our solid state drive. And we can see right here, U9300. What are you? This looks like some sort of power management controller, and it looks like it's going to be specifically for our SSD. This is actually what I thought it was, the name right here, Piccolo. I've seen this on previous units before, so I think the name of this chip is Piccolo. In fact, we can actually see right here, Piccolo PMIC, Power Management Integrated Circuit. This is going to be what generates power to send these different power rails right here, the VRP1VT hot feedback, the switch line, the VRP1V8 cold feedback. These are all different power lines that go out to it looks like they're actually buck converters specifically, which is what's going to power our SSDs. So that could definitely be why we're having issues. Let's take another look with our microscope and see if there's anything else we need to address, because it looks like we may just need to replace those two components. Hi there, you got me steak? Yes, it does look like someone pried off that component. It doesn't look like it was intentional though. That definitely seems like accidental damage from removing the bottom case. Alright, so I don't see anything else obvious on this side of the board. We're going to have to end up pulling the logic board out anyways because I don't want to do any type of rework while it's still in the housing. But I'm thinking this may be our only issues right here, is we have a thermal sensor just from accidental damage, and then we somehow have this capacitor that is going to be responsible for, actually I'm just thinking about it. It's a capacitor, as in, it looks like it might be a smoothing capacitor. And I guess if it's not properly smoothing like it should, then we're not getting a nice clean signal to turn on our SSD. I'm just going to go ahead and make sure that there's no shorts that potentially damage this. Nope, doesn't look like there is. So let's just go ahead and start removing the logic board. Three other caps on that rail shouldn't cause that much trouble. That's exactly what I'm thinking too, because it looks like it's going to be smoothing capacitors, so if that one capacitor is completely gone, I don't think that's going to be the main reason why we're having an issue with our SSD. So that's possible user damage from when the bottom case was being removed, so there still might be something hiding underneath the logic board when we pull it out. This screw right here for the EDP cable seems to be really stuck in there. Two of them are different values though, who knows? Well, that's what we're going to try to figure out. There's so many different screws on this model. We have a series of T5 and T4 that we have to switch back and forth between. And we even have T3 up here that's holding the, I guess just the hinges where they go onto the top case. I loved with the unibodies how everything just came off with a T6 screwdriver. And then when they released the retinas, like the A1425, A1502, A1398, you just used a T5. And I think the MacBook Airs, yes, the MacBook Airs were the exact same way, just a T5 screwdriver. Now, with this one, you're going to have a T5 for some of the logic board screws. You're going to have a T4 for like the EDP screws. I think even a T4 right here for these cowlings for the different flex cables. And then you have the T3s for the hinge covers. There's so many different screws in this model. And I can't really say exactly what the intentional design was for that, other than to deter people from working on their own computers. I don't know. Never associate malice to what can easily be explained with ignorance. Could have been just a new engineer who wanted to try different screws. Or maybe there's a T5 screw shortage and they just wanted to start using T4 screws. I do really like the design of these models. I do think that they're a little too thin. If they were just as thick as the Retina models, like the A1502, I think these would be very resilient machines. But I think we've kind of just gotten to a point to where the mentality that thinner is better, where we've gone too thin. kind of like with the iPhone 6 and 6 Plus when they first came out. You had bend gate because they were using, I think it was like aluminum 6000, and then with the 6S, they came out with the aluminum 7000, which was like aircraft material, so it didn't bend as easy. It's kind of what reminds me with this specific computer. It's just too thin. Someone tried to open the bottom case to begin with for a reason. You're not wrong. In fact, the client had actually informed me that he was having an SSD issue prior, and when he opened up the bottom case, that's when he discovered that capacitor was missing. And since the pry damage came while trying to remove the case, that would indicate problems damage prior to pry damage. You're not wrong. That is a very, very wise observation. So we're going to have to distinguish the difference between the pry damage from the actual root damage or root cause. Why is this not working like it should? Alright, and then whenever you're pulling out one of these logic boards, just because there's so many different flex cables, you want to make sure that everything is properly unscrewed and that all the cables are out of the way. So that's what I'm doing. I'm just kind of gently pulling up on the board while just moving these cables out of the way. This Wi-Fi antenna will always get in the way, so we just got to make sure to scoot that over. Alright, let's save our screws for later because we don't need those at the moment. Alright, let's use our eyes and just kind of inspect around this part of the board as well, now that we have it removed. And let's remove these fan rubber gaskets for the time being. And I'm just checking to see if there's anything obvious on here. And just a little bit of dust on that CD3215. But no signs of liquid damage. Doesn't look like anything's exploded. Okay. So let me grab a charge port. And now what we're going to have to do is just kind of look at all the different power rails or LDOs that make up powering the SSD. There's probably going to be signals coming out of the Piccolo, the PMIC. Make sure that those rails are present. Okay. So first I want to see what voltage is actually on PP1V8 SSD cold. Just for morbid curiosity. Why, thank you, OpenTrap. I appreciate the feedback. I myself want to fall asleep as well. I was working till about 4:30 a.m. this morning taking care of some boards. So I only got about 3 hours of sleep before opening up the shop. Okay, so with power going into the charge port, we should be getting a reading of 1.8 volts. And we're getting nothing. 0.0 volts. Now let's remove power and just measure to see in resistance if there's any obvious short. And it doesn't look like that. It's about 5,000 kiloohms and going up. Okay. So let's see where the signal is being generated from. I think we've already said that signal is going to come from U9300, which is going to be the power management IC. That Piccolo IC. But back on U9300, it looks like power going into it is going to be PP3V3 S5 SSD. I'm curious if this signal or this power rail is even going to be present with that Thunderbolt thermal sensor being removed. Because I'm thinking, A, either the thermal sensor is just going to not work, and so the fans will run high, or B, it might go into a failsafe where it thinks that the computer itself is exploding, so it's actually preventing itself from turning on. But we are getting 20 volts at 0.8 amps, so the computer is turning on. Let's check PP3V3 S5 SSD and see if we have 3.3 volts. Okay, so it's going to be all these different components over here. Okay, 3.3 S5 SSD is present. I think in order for us to properly diagnose this, we're going to have to end up fixing the user damage before we actually start troubleshooting where the initial damage is from. So I'm going to go ahead and try to scrape into some pads. It looks like we might still have a ground pad or two there. And the rest of these are going to have wires created. We're going to have to create our own jumper wires. What I'm curious about is this. Is this ground or is this going to be a via? It looks like we have some vias here, here, and this is just going to be all around some jumper wires. So let's take a look back on our screen. And that's not connected, so that's perfectly fine. And yes, those two there are still ground. So let's get to fixing the damage traces. Oops, wrong microscope. Not connected, fortunately. You're absolutely right. I'm very happy for that. So what I'm going to do is just use my scalpel here and just expose the traces that are left behind. This trace looks completely fucked, so I think what we're going to have to end up doing is just soldering a wire directly from this component here to this pin. It looks like it's going to be pin 2 on U5860. And then same thing here. I'm going to have to solder that. And let's try to expose this via, the trace to this via. Ooh, and then right here we actually have another via underneath. What is this? That's the one I'm worried about, because all the other ones, the vias are on surface level, but this, we might actually have to run a jumper wire if we can't expose that via. It goes to the other side of the board. So it looks like R5861 has a wire, essentially, or a hole, that goes directly to U5860. So we can try one or two things. We can either try to expose this via underneath that's going to go through the board, or I normally don't do this, but we would probably have to run a jumper wire from one side of the board onto the other. Let's see if we can just start exposing this. I'm actually going to have to switch razor blades to something a little sharper. This scalpel is just a little dull. So if you're looking for a scalpel, what I would highly recommend would be the brand Feather. I think I actually got this off Amazon, but it's very, very light. It's the perfect weighted scalpel in my opinion. It's very light, but at the same time, it's got some weight to help balance. It is a surgical scalpel, so I'm sure there's a lot of thought that was put into designing this. But you can get a pack of surgical blades. I want to say I paid $40 for 100. And then this is just like a blade disposal. So I can just put the blade in here, press this button on a working day. Come on. And in theory, you should be able to pull this out. And the one that I highly recommend is going to be the number 11. That seems to be the best one that I found. Very, very sharp. It is a surgical scalpel, so you want to make sure not to cut yourself. Perfect. And it's sterile if you really care about that. Okay. Alright, so let's see if we can really get into here. So you can kind of see there's a hole or a piece of copper that is trying to expose itself. And there's another piece of copper right here that we don't want to expose. So that's going to be ground. We want to keep that away from our actual via right here. So I'm being very mindful to just expose this via and try not to expose too much of the copper around it, because we don't want to bridge it to ground. Okay, it's a little bit more than what I could expose earlier. So we may have to run a coil jumper right there, and that's something that I've done for iPhones. So we're probably going to have to end up doing that for this specific trace. So this part of the stream is probably going to be very boring. It's just going to be me trying to fix vias. don't really have too much to talk about since my mind's a little burnt out today. Alright, so see how this one was surface mounted? You could actually see like a perfect circle of where it was coming out of on the board. That's kind of what I wish was going down here on this pin, pin 4. And I'm just gonna end up just cutting this trace since it's already loose. Yeah, this very much reminds me of iPhone board repair. I'm excited to see what the M1 processor boards look like, because my understanding, and you can correct me if I'm wrong, the M1 processor is basically just an iPad Pro processor. And I know the architect, or just like in the power on sequence for an iPad Pro processor is going to be different than on a MacBook. So it's exciting to see like the two different sides of the repairs, Mac repair and phone repair, are going to have to kind of help each other out, join forces, and learn how each of them work. Because I feel like it's going to be a perfect mix of iOS or iPad OS repair versus Mac OS repair. Okay, so that trace looks good. And these down here are loose as well, so we're just going to pick these up and remove them. And this one almost goes all the way back to this component. Yeah, we're just going to have to end up soldering a wire directly on this side of the component. Okay, not a problem. But it looks like we might be able to run a wire from this part of the trace if we can expose it. Okay. I would say all traces have been... Ooh, I don't like how that one is wiggling. This one almost came up with it, as well as this one. Let's make sure that they're still touching ground. Cool. Those parts are still there for now. Now we need to address pin 4. I'm going to try a technique that I've done before with a Nintendo Switch. And what we're going to do is we're going to take whoops, wrong camera. What we're going to do is we're going to take an IC that we have, like we have an old SMC here that's dead. Let's take that. And we're going to use one of those traces, or one of the pads. Let's see, is this one? This one looks dirty compared to the other one. We're going to take one of the pads and we're going to solder a wire onto it, and we're just going to wrap the wire or wound it around on that pad. Maybe it was the CD3215 that we used, because these SMCs look like they haven't had the solder removed yet. Okay, we'll just end up going with one of these SMCs. We're just going to have to remove some of the balls that are on it. And we'll need some jumper wire. Let's see if this mechanic jumper wire is going to be thin enough. If not, we may have to switch out to iPhone jumper wire. Yeah, it looks like this stuff's actually going to be pretty... I apologize. I need to put some lubricant on my microscope. Okay, so let's really dive down and see. This might be a little too big for that via. The rest of this is going to be perfectly fine for the jumper wire for all the other pads. So we're going to have to pull out some iPhone jumper wire. This stuff is 0.009 millimeters in diameter. Very thin stuff. Alright, since we're going to start soldering, we're going to need to turn on our fume extractor. So this is a method that I'm not proud to have learned. I had to do it on a Nintendo Switch that had the traces damaged on it. And I had to do about 12 of them, if I recall. It took a very, very long time to do. Alright, so what I'm going to do is just expose or clean up where these solder balls are to expose just the pad. And let's kind of give it a cleaning because that looks bad. Okay. And this is the part where I'm actually going to have to switch out my micro pencil. I have a knife tip on it. I'm going to switch it out to a different tip that's a little bit smaller. Let's see. Let's see. I would switch it out, but it looks like that the iron is already on, so it's already heated up to its max capacity or thermal design, and I can't think. It's already set to its high temperature. We don't want this IC to move, so I'm just going to grab this clamp that I have here. Alright, so now what we're going to do is grab our jumper wire and solder one part of it to one of these pads. Oh, hands are really, really shaky right now. Come on. And it always looks even shakier whenever it's anything to do with like iPhone repair. It's actually one of the main reasons why I don't do iPhone repair that often. Okay, let's see if that's on there. Just cut that tip right off. And then let's do a length. See, this might be a little too long, but let's cut down here. So then what we're going to do is wound the coil. It's going to just go around into a circle, and we're going to make a coil. Wow, you really can't see that. But we have a tiny little coil there now. We're going to use that coil to make a pseudo pad for our ripped via. And so if you do iPhone repair, you're probably used to making these type of coils. I myself am not. I'm not as good as some technicians I know in the Rossmann Discord, the iPhone technicians. They have much steadier hands. I've actually been quitting caffeine lately just so that I can focus on not having such shaky hands. Alright, and then now what we want to do is put kind of a little dab of solder in between that jumper, that coil, and it's just going to make a little pad. Okay. It's very, very hard to see, but we have a little coil. So now we can just put our SMC away for the time being. It's just a donor SMC. No, I should say it's a dead SMC. It's not good for donoring at all. And let's bring it over to our via and attempt to put the coil down in the hole of the via. I almost feel like I'm going to have to switch out to my 0.7 Barlow lens. I'm using my 0.5, but it's too far away. Oh wow, that is really small. That probably wasn't big enough. Okay. Let's see with what we can work with here. And just put a tiny dab. That's kind of a big dab of flux in the way. Alright, and we've timmed up that tiny, tiny little via. So let's see if we can now put our coil in its place. I'm not in any way an expert at doing this. I've just done it once before. Okay, I think we got something. Before I cut it, actually, let's make sure that we're not touching any of the other copper that was on the side, which was ground. So, let's poke this. Awesome. Now what's going to make this difficult is figuring out if we can probe this side and the other side at the same time to see if we have continuity. That would be pretty tricky. So what I'm thinking about doing is just trusting in my abilities that that is soldered on, and if it doesn't work, then what I'll end up doing is running that jumper wire from one side to the other, because we'll have to use a jumper wire anyways for continuity. Let's go with that method. So now we can go ahead and cut this tiny, tiny little iPhone wire. Don't need you anymore. And try to touch up this area some. I'm also going to use some mask to make sure that that coil that I made doesn't try to fly away. This is where I would need to contact Joseph Hughes from La Clínica de la Manzana. He is amazing when it comes to this type of work. Hello, Tim. Thanks for joining. Right now, I'm in the process of trying to basically do an iPhone repair on a MacBook. A tiny little VIA that got damaged. And I'm trying to see if I can run a coil to fix the VIA. But if this doesn't work, we're going to have to end up running a jumper wire from one side of the board to the other. You know, I'm going to actually try a different method. I'm going to try a method that Joe did in one of his videos, where he treated the mask as if it was like a paint-in palette. So he put some masking on a surface, and then he used tweezers, or in my case, I'm going to end up using my scalpel, and he just picked off from his surface and painted. Let's try this. Yeah, that's actually much finer control. Are all those pads missing? Just about. The only two that are left behind are the ground pads. All the other pads, the traces or the vias are exactly exposed on top, so they won't be too difficult. But this one right here, pin 4, it has a via that goes through the board onto the other side, which touches a resistor. And what I'm trying to do is I made a coil out of some iPhone jumper wire, and I was able to touch the via pad. And now I'm in the process of using some mask to hold it down in place. Okay, it's gonna be something, so let's start with that. And I'm just gonna cure this under our UV lights. Let's see if that cured. We may have to use a little bit more. Yeah, that cured some, but we still have a giant hole right here, so let's see if we can fill it in with a little bit more of this mask. I actually used some of this green mask on some standard green PCBs the other day, and it made the jumper wires disappear. So I'd like to get my hands on some black mask, since these boards are black, to make our jumper wires disappear as well. Sounds like you need some silicone spray on your microscope stand. Yes, yes I do. You notice that? I have been using WD-40, but silicone spray? And that I've heard of, I've just never actually used myself. Okay. Being very self-conscious about the sound of my microscope now. I have black, blue, red, green, UV mask. LOL. Nice. You have to send me a link of where you get them from, because admittedly, I bought this stuff a long time ago. Probably about a year and a half ago now, and I got it from Mobile Centrics. I didn't actually reach out to a vendor and get it, or mechanic directly. So this was the only color they had was green. So every time I do like a jumper wire for a demuxed 2011 15-inch, it just kind of looks like there's boogers running down the side of the logic board. Okay, are we done? Or are we still gonna have to use a little bit more mask? So you can't really see, but I got this nugget right here. That's what I'm gonna call it. This is a little solder nugget that's sticking out, and that's what we're going to be soldering our U5860 down onto. So I think at this point, because this is a good cure. At this point, it's time to just go ahead and get a U5860 from a donor board, and then we're going to run our jumper wires. So let's grab a donor board. Alright, this is going to be our sacrificial U5860. Ironically, it's coming out of a logic board that does in fact have a dead SSD. Now the SSD isn't just one chip, it's going to be a series of NANDs that also connect to an SSD controller. So I think in this one it was the actual, one of the NANDs was shorted, and from a very, very long night of trying to reball the NANDs, I found out that you actually can't replace them. So it was the customer, not another store, who both said there was an SSD problem and tried opening up the machine. That is correct. This computer has not been to any other shop, allegedly. That is what we've been told. The history we have on it is that one day it just started showing the question mark with the folder with the question mark, and so the customer took it upon himself to open it up. And I don't blame him. I probably would have done the same thing. And it looks like in the process of opening up, there was some pry damage. So even after we fix all this, there's still a chance that we might be looking at another shorted NAND. But we'll get to that part once we fix this damage first. Oh, we actually don't have the temperature set to the right temp. So most solder melts around 380 Celsius. And the reason why there's cowlings on here, they're almost like interference blockers or a heatsink, you could say, for the NANDs. And they act as a heat shield as we're heating this whole entire area up, because some of the NANDs are actually underfilled, and we don't want to apply too much heat to a board that's been underfilled, because then we might expand some of the balls underneath the NANDs and get us into an issue further down the road. And if I were to treat this like iPhone repair or just BGA rework repair, what I would do is run a trace jumper from the traces and kind of do a coil at the end to make a pseudo pad. What I'm going to try this time is just put this down directly on top of ground and then run solder pads or jumper wire directly to the pins or pads exposed onto the right side or onto the sides of this specific component. Oop. No, don't disappear. Come back here. And my hands are a little on the shaky side. So I don't understand. I actually just ate dinner not long ago. Alright, so it's going to take a little while to wiggle just because the two pads that are actually alive still are going to be our ground pads. I'm probably rethinking doing this jumper issue, or not making a coil where the traces are. I might need to still do that. Alright, so the chip is in place, the IC package is in place, and now we're going to have to run some jumper wire. Okay. The reason why I'm thinking I might regret this is while I'll be able to run jumper wire up against the sides right here, no problem, I see it being an issue on this side just because of the angle I'm going to have right here. I'm going to start on this side first, because if I can't figure this side out, then I'm going to have to pull this IC off and end up just running some traces with some coils. So let's rotate the board so I can get a better angle. Okay, so we already have our ground right here on this pin, and that pin's going to be, just so I understand, that's going to be pin 6. So pin 7, we're going to have to run a wire from here to here, pin 8 from here to here, and this is going to be the trickiest part, pin 9 from here all the way to here. Just because we might interfere with our pin 8. So let's start with pin 9 first. Let's put a dab of solder and grab our micro pencil with a knife tip. Put some solder along the edge of this package. Something that our wires can really grab onto. With this LED, you really can't see that well. I don't think this is going to work this way. I think I'm going to have to remove this, what are they called, QFMs? This package, and hopefully in the process I'm not going to rip up that, that via that I made. Because it looks like I am going to have to run some jumper wires from the trace and then have like a little pseudo pad for it to kind of mount itself onto. Alright, well, let's go ahead and remove this. Something I didn't see until we actually put it on. Okay, it looks like that our little nub, or nugget right there in the top left corner, survived. Alright, well let's just set that IC, the U5860, to the side. And let's start working on making some jumper pads. Alright, so I'm just tinning up the existing traces that are here. Come on, hands, don't fail me now. Oops. Yeah, I don't mind running jumper wire, but when it gets to this level, just gotta be a little bit more patient. And you can't get aggravated. It's very, very easy to get aggravated at jumper wire repairs. Alright, so let's cut to about right here. Okay. And this is the part where you guys are going to criticize me because I'm not the best at wounding a coil in this direction. Alright, that's not the worst. And now let's just kind of put a dab of solder in between to make this pad. It's definitely not the worst. I've done much worse than that. That's okay. Alright, so that is 2 down. Let's move on to the third one. Now this one we're going to have to solder directly onto that component. What is that component anyways? It is a capacitor. It is RIO underscore TBT thermal sensor D1 underscore P. Don't know what you want to do with that information. Because off the top of my head, not sure what that all means. Okay. So let's touch up onto this capacitor. Okay, let's see if we can make a coil out of this one. Yeah, like I said, this is going to be the most boring part of the stream. Okay, let's try cleaning this up a little bit. Just before the, not the resin, but just before the Amtech flux starts to turn into like a resin-like substance. And I don't want to rip my traces off, so I'm just dabbing this area with a Q-tip and isopropyl alcohol. Now you can see this pad is trying to come up. But we want you guys to stay down. Alright. Let's go for the fourth jumper, and then after that, we will go ahead and put some more masking before moving on to the next side. Yeah, my hands are too shaky for just doing iPhone logic boards all day long. I do those strictly for data recovery. But when I see people like Swedish Chef doing CPU replacements on the iPhone 10, 10s series, no, those guys definitely have a whole different skill, which I will never get to. They're really good at what they do. It's not boring, it's a different way of doing it than I saw Paul S. from Rossman Group doing it when we had a pride victim like this. So I'll get to compare techniques. I actually haven't seen that one. Probably should. He'd probably have a much better way of going about this, because I'm just treating this like it's an iPhone. Like I said, I had a Nintendo Switch a couple of months ago where someone had ripped the pads off, and it was just as bad, if not worse than this. But there was about 12 of these I had to do. So that night I learned how to make coils better. Not good, but better. Better than what I could before. That was a sad night. I think I was up till about 6 a.m. and then we had to open up the shop at 9. So I ended up spending the night. Thank you for the encouragement, though. That makes me feel better. Alright, so the pieces are there. Now let's just clean it up and put some mask. And we can move on to what I feel is going to be the more difficult side. Yeah, and these are the type of repairs I'm actually happy that we do when we're closed, because I would be interrupted so many times right now. And this is one where you just kind of have to get into your zen. Just find peace. Just kind of put a dab there and we'll spread this out. Alright, so now what I'm going to try to do is hold this area down while I hit it with the UV light, making sure not to actually look inside of my lens as I'm hitting it with the light, because I already have bad vision as it is. These two look fine. This one on the side is going kind of at a 45-degree angle. It's still going to make a connection, but it's just not pretty. Alright, and just try to put some mask around the sides. There goes that microscope again. Alright, let's kind of rest this on top real quick. This is interesting to watch. I'd love to have all this knowledge and skill, but I can't afford the time and investment, unfortunately. Biggest repair I've done is baking an iMac GPU in the oven. LOL. I know that is a temporary patch. I've had many people say success with that repairs. That is something that's not for the weak-hearted. However, if your GPU does fail, I'd probably recommend getting an NVIDIA Quadro K4100. I think you have to do a modification to the heatsink in order for it to actually fit with the squeak, in order for it to actually fit the graphics card onto the heatsink. But I've heard that, one, it's a better graphics card, but two, it has built-in or native brightness control for that specific graphics card. I personally use the Quadro K2100Ms here. I think they're like 2 gigs of VRAM, but you have to flash the BIOS in order to get it to properly work for the boot screen. If you replace the graphics card without flashing it, then the screen will remain black until it boots into an operating system. This is more of like a sadistic hobby, you could say. I love doing what I do. Fortunately, I was able to actually turn it into a career where I can offer every single day. But you're absolutely right. It is an investment. It is time. And I think time is probably the most important part spent learning how to do these things. I myself have been doing board repair for probably about 2.5 years at this point, and I'm nowhere on the level of some other technicians that I know in the Rossman forum. So it's just one of those things you just, like I said, sadistic hobby. You kind of just keep at it. you stay here spending the night, or stay here until 4 a.m. working on repairs. You get that a dopamine rush whenever a computer works, and that's kind of the thrill that I look forward to keep wanting to do this type of repairs. That's my whole rant about that. Alright, let's see where we're at right now with this. It's not pretty, but I think it's going to be tolerable. So now let's go ahead and make these other jumper wires. I'm going to change my angle, or just rotate the board. I could be at home with my wife and my dogs, just resting in bed, watching some Netflix. But it is almost Christmas time, and repairs need to be repaired. We've had a huge influx in iPad repair lately. It seems like people are re-gifting their iPads to their children. It's actually gotten to the point to where customers are actually not moving forward with repairs because we told them we're not going to get it done before Christmas. That's been kind of the deal breaker. And honestly, it's better to be upfront with a customer than you overpromise and underdeliver. If you say, yeah, we'll get it done before Christmas, and you don't get it before Christmas, that just looks really bad. You're setting the customer up for really, really bad, or high expectations, but you're going to underdeliver, which just doesn't look good. It's just better to tell them what's going on. And we've told people, yes, you know, we're past the point to where we can actually get boards or iPads finished before Christmas now. So it's going to be maybe Saturday or maybe even following Monday. And they've thanked us for being honest with them, and they decided to go buy a new iPad instead of waiting and getting theirs fixed, because everyone else in town seems to be busy too. Why can't I grab this? There we go. On top of iPads, we've had a lot of people call about Apple Watch repair. I think kind of the same deal. They're fixing up their old Apple Watch to give it to someone, friend, family. We don't do Apple Watch repair anymore due to the virus. Just part costs have gone up. But Apple really broke the system for repairing Apple Watches, because before they would only carry one series. So you had the Apple Watch, and the Series 2 and the Series 1. Then you had the Series 3. And then when they came out with the Series 4, they still had the Series 3. And they came out with the Series 5, they still have the Series 3 for like $250. Then they have the Series 6, they still have the Series 3. So, honestly, it doesn't make sense from an economical point of view. That it's going to cost about $230 to fix an Apple Watch, when you can go buy a Series 3. Admittedly, it is 3 series older, but Apple's still selling them for only $200. So we've just been telling customers it's probably better to just go ahead and get another Apple Watch. And I hate that, because my motto here is repair, don't replace. But the Apple Watch, You know, if Apple still wasn't selling the Series 3 Apple Watch at that price point of $200, and you know, fixing an Apple Watch for maybe $200, $230 versus buying a new Series 6 or SE would probably make sense, but it doesn't anymore. What is your most common iPad repair? At the moment, it would be iPad 7 digitizers replacements. Board repair-wise, it's going to be charge ports. Something about those charge ports, they just break very easily on the inside. And it's not the customer, it's just the charge ports are just, they're not the best quality. But yeah, at the moment, it's going to be the iPad 7. What I like about the iPad 7 is the iPad 8 uses the exact same parts. iPad 7 is an iPad 8. Yeah, mine is 6th and 7th and Air charge ports. Yeah. We fixed a lot of 5s also. I think just today we had 2 7s and 2 6s get dropped off. People have been even fixing their older ones. Just earlier, well, I guess it would have been last week at this point, we fixed a couple of iPad 2s and 4s. I think today we did 2 iPad mini 1s. And we've expressed to customers, you know, these don't get the latest operating system anymore, and they're fine with that. They just want something to be able to browse the web with. We even had an iPad 1. I have not seen a first generation iPad in a long time, but yeah, one came in, and we pretty much told them, like, please do not get this one fixed. Yeah, mostly iPads. I have another technician that's been stuck in SSD upgrade purgatory. He's just been taking apart iMacs, and he's done with it. 2 more iMacs come in. He fixed those 2. 4 more come in. Which I love doing SSD upgrades. Seeing the joy on a customer's face when they're dealing with a hard drive that is so obnoxiously slow and they get a solid state installed afterwards, it's amazing. It's almost like when you tell a customer that you can replace the battery in their phone and that they don't have to buy a new phone instead. I had a conversation with a guy. I'm just rambling at this point, but I had a conversation with a gentleman earlier, and he said, you know, the strangest thing is I notice every time my 2-year contract is up, my phone starts acting up. It's almost like these phones are purposely programmed that after 2 years they start dying. Is that true? And there are plenty of conspiracy theories. But the one thing that can definitely be truth is that the batteries are probably good for about 18 to 24 months. Coincidentally, right around the 2-year contract hold with Verizon or T-Mobile, AT&T, whoever your carrier is. And then when we tell them, yeah, you know, we can replace the battery for this amount of price, it blows their mind, and they're so happy. And, you know, the iPhone SE, it's $400. It's a good phone, but when you're looking at the prices of the iPhone 12, it's kind of hard to think, I might be able to drop $800 to $1,500 versus just doing a battery replacement. So battery replacements and SSD upgrades are 2 repairs I love doing because you really see the instant satisfaction in customers' faces, like immediately once the repair is done. I love that. But the iPads, it look like they're all for children. I haven't really seen an adult use an iPad lately, unless it's a Pro. The iPad Pros always get used for some business related, or even for drawing, but yeah, the iPad Airs, all the way to the 8th gen. It seems to be just like the new age console for children. And it kind of makes me feel old. Now, when I grew up, we had the NES, and my main console was the Sega Genesis. But now kids are just walking around with their video game consoles. And my wife and brother, they're always like, these kids need to get off their iPads. Just like, you guys are becoming our parents. We were doing the same thing, except we were tethered to a television. Or a stationary computer. Yes. I didn't have that luxury as a kid, but yes. It is also the same concept. Because an iPad is just a mobile computer. Or like a laptop. It's a laptop, but it's just the screen. It's a screen top. Now, I actually didn't start getting into computers until 2009. And I've never looked back since. It's been great. Tethered. Mm-hmm. Now my brother-in-law has the new, I want to say it's the new Oculus, to where it syncs with his computer, but it's somehow wireless. So now he's no longer tethered whenever he wants to do virtual reality. These pads are coming out a little bit better. Alright, one more pad to go. And where'd our jumper wire run off to? Wireless Oculus, so now he's free to run into a wall, and even planned obsolescence is evolving. I mean, I don't know if it's wireless, to be honest. I have not kept up with the virtual reality world. I know the last thing I paid attention to was Steam coming out with the HTC Vive, and I don't even know how many years ago that was. But yes, you're right. You could just run into a wall and break your screen. I remember the first Oculus, whenever I had a friend who had one, the developer kit actually had a Samsung Note screen in it. You could actually peel back the face of the Oculus, and inside it actually said Samsung Note. And this was the Dev Kit 2. I want to say this is probably like 2013, 14. That was the last time I messed around with virtual reality. Okay, I think we're getting towards the end. This is the end. Beautiful friend. Alright, let's try to put one more piece of solder in between that sad, pathetic excuse of a coil. The Oculus Quest 2 is completely self-contained, actually with a VR/AR specific Snapdragon processor. Oh, that's cool. I think he had the Quest, because he got it over a year ago. I didn't know that they came out with a Quest 2, but the name sounds familiar. That's really cool that they're able to put all that, though, into just the headset. Okay. We're gonna have to make this do. So now, let's clean up the area one more time and put some mask over these pads. I'm trying to do a PRAM reset on a 2009 Pro that is EFI locked and the left command button's not working. Now, never mind. I probably shouldn't be giving that type of advice. Can't you use an external keyboard? I can't remember if you can use an external keyboard on a 2009. For resetting the PRAM, I mean. Looks like we have too much mask here, so I'm just going to use my tweezers to kind of scoop it down. Okay, so now I guess the next question is, do you have an external keyboard? let's grab our UV light now. Using external but doesn't respond. Yep. And Tim, this is a dumb question because I don't really work with EFI lock devices that many times, especially an older one like that. But can you even perform a PRAM reset if it's EFI locked? In 2009 is a very interesting year because it was the last Core 2 Duo machine. So doing EFI on lock is different than if you were to use a 2010 with like an i5 or i7. Oh, I know exactly which reputable Frenchman you're talking about. I don't like how this is just kind of freely floating here. These two look fine, but this needs to go back down. In fact, I actually think it has a little bit too much solder on it. Okay, it's a little bit more flat. So now let's try to add just a little bit more masking around that specific pad. Oh no, I just saw my little nugget's gone. Where did it go? Oh, that makes me sad. Okay, well let's finish curing this and then I'll try to address pin 4. Yes, he definitely knows a lot of programming. A lot more than I'll ever know. I actually went to school for programming. I enjoyed it. But I learned more at a repair shop than I did at my community college. So I pursued that instead. It was bad. I was actually in college for about, I'm trying to remember, I think it was 2.5 years. And yeah, I picked up an internship at a local PC repair shop. And within the matter of 2 months of me working there or interning there, I had learned more about computers than in the 2.5 years I was in college. The thing with coding that I really have a struggle with is getting colons and semicolons confused and breaking code. And oh man, the worst part about it, in my opinion, the worst part is they were teaching me Visual Basic, which I later found out is not really a commonly used programming language. So I understand, like, we were learning the syntax of programming, but why would you teach us something that we're not going to use? It just didn't make any sense. Things got fun when we started learning C++. Okay, so now I need to figure out what to do with this section. I think I'm going to try making another pad or little coil, but I'm not going to use the iPhone wire. I'm going to try using this jumper wire. It might be too big, but let's see what happens. Okay, let's see if we can just kind of plug that in there. Cool, it looks like that we're in. Now can we save it? Before I start winding that up, I want to see if that is touching ground. So I'm going to put my multimeter in continuity and just touch that probe point that we just made. No immediate signs of ground. I think we're fine. Let's see, I've done 7 of these so far. That night where I had to do 12 took way longer than this. Because I was still fairly inexperienced with making these kind of coils. And I still suck at it. Are we gonna make it? Are we gonna do this? No. Why? I don't like this. I really, really don't like this. Oh, that was disappointing. That was really, really sad just now. Oh, man. Okay. Find your zen. Release and let go. See, we can still kind of see that pad. I'm just gonna have to dig just a little bit deeper, but it's still there. There it is. That little nub. Alright, and I still kind of have this mess. Let's see if we can reattach that. Okay, it's on. Tim, if you don't mind me asking, why exactly are you working on a 2009? That went a little too far on the side. We're gonna have to clean this up. Well, all I did was spread it and make it worse. But it is still exposing our pad, so it did what it needed to do and then some. So let's try cleaning this up some. Alright, so let's hit this one more time. It's a customer commercial. I told him I don't normally do EFI on logs, but his customer agreed to pay the asking fee. I didn't realize how old it was until he brought it in. I actually had that same issue, or not issue. I had that same interaction earlier today. I had a gentleman bring in a Mac Pro. I was under the impression it was a 2010 model. Actually, it was a 2006. So it could only go to macOS Lion. Can't tell you the last time I actually had to install macOS Lion on a computer. Don't normally work on these older machines, but I felt bad since since this was what the guy could afford. Okay, it's understandable. Back into that whole repair, don't replace mentality. Because 2009, so this can only go to El Capitan. I know there's a lot of software incompatibilities with that. Alright, and just because this pad is very sensitive, I am going to put a little bit more masking on it. I have an external boot drive that has Mountain Lion on it. Yeah, that's one of those OSs that I really don't see anymore. Especially Mountain Lion. This may be an unpopular opinion, but I feel that Mountain Lion was the equivalent of Windows Vista to Mac. It just wasn't really that great of an operating system. Or maybe I'm thinking of Lion. I think Lion was bad, and then Mountain Lion was okay. So it was like the Windows 8 wasn't the best, and 8.1 was okay. Hello, Sam. Good to see you too. Everyone say hi to Sam. A replacement logic board for this is like $80. Yeah, that's one of those things where you have to figure out, is it worth is it worth actually fixing the logic board, or is it just spending the time? What do you value more, the $80 or your time? Okay, I think we're now at a point to where we're ready to go ahead and try putting this this package back on. All right, it really isn't the best, but let's get it going. Now, where did I set that? I think this is it. Now, Sam is actually my wife. She's at home right now watching. She's just jealous that I'm diverting my attention right now instead of being at home. Trust me, I wish I was home. I'm so tired. I was up till 4:30 this morning fixing a MacBook Air. Okay, we really only have one shot at this, and it doesn't move around much. So what I'm going to try to do is lay this on top and use very low output airflow and kind of flow it into place. So let's drop our airflow down. And we don't want to use too high of a temperature because we don't want to potentially melt the solder balls under our underfill ICs for our NANDs. I was up till 2 watching Korean dramas, no regrets. I was up till 5. Yeah, we're all just late night owls then. Alright, so the chip is wiggling a little bit. Just fine, I just don't want it to blow away. Alright, it just moved a little bit. It's kind of dancing into place. It's either gonna work or fail amazingly. Oh wow. That is very early where you guys are at. It's 11:30 p.m. here. Alright, let's stop and see where we're at with this. So what I'm worried about is going to be this pin right here. I feel like this is going to be touching these two pins. So what we're going to need to do is check continuity between these two components and see if they're bridged. Excellent. Doesn't sound like they're bridged. What about this side? That side seems okay. Okay. Wow. This might work. Let's get a different view of this. That looks like that is soldered on to me. Wow, that actually worked. Alright, let's look on the other side. Someone just got what? Are you trying to say something in Spanish? Okay, let's look over here. Those all look soldered. Wow. Okay. I know you can't really see just because my LED isn't the brightest whenever it's away from my actual desk. I think that has something more to do with the auto brightness of the camera lens. Alright, let's move forward. Let's go ahead and replace this capacitor. And I'm actually going to switch over to my micro tweezers for this. Come on. Don't die on me yet. I think my tips are dying. They're fine once they heat up, but when they first make the switch, they definitely like to scream. The chancla. I thought that's what you were trying to say. You know, sometimes when people get out of line, you just gotta throw a sandal at them to get back. See, I never remember that growing up. My mom claims that she used to throw sandals at me when I got out of line, but I don't remember that. Loose thought, is the trace running under the capacitor damaged severed? Didn't look like it. Yeah, the capacitor or the traces look fine. Oh wait, I see, the other capacitor. So what I did instead was actually just solder directly to the capacitor. But you think there might be a via underneath there? Let's take a look at it. Never mind, lifeboat, minimal chance of interference. Okay. Yeah, that doesn't look like there's a via. It looks like that's just a straight pad. No, the one where the cap was pried off. No, I checked that. There doesn't look to be any damage traces. That is a good afterthought, though. Because it looks like this side's ground, and then this side right here is going to be our 1.8 volt line. Unless there's something that I'm not seeing. The trace on the board, not the board view, running everywhere, but it's a dummy lifeboat line. I love you and I miss you too. I'll talk to you in a little bit. Oh. Alright, let's see what we were talking about. There's a trace on the board, not the board view, running everywhere, but it's a dummy lifeboat line. Oh, okay. Well, if it's a dummy lifeboat line, then we should be fine. Okay. Hopefully, that via that I made that iPhone jumper with is still perfectly fine. If not, I'm going to have to somehow figure out a way to run a wire to the other side of the board. I just don't want to have to pull up this MOSFET anymore, or this QFM anymore, because I'm probably going to remove those traces and have to redo all my work. Alright, let's see if we have any change now. And then we can kind of start looking back at the SSD issue. It's a horrible squeak, I know. I'm sorry. The Q-tip really puts things into perspective. Yes, this is very small. I had my microscope zoomed in all the way just to work with that tiny little trace. I was contemplating on actually switching out my Barlow lens so that I could get a little bit closer. I have a Barlow lens that I specifically do iPhone repair with, and then one for Mac repair, and I was about to pull out the one that I use for iPhone repair. Alright, so let's weave through this mass of cables and connections. Don't forget the power button. That likes to hide, because it's right underneath the auxiliary jack cable. Okay, let's make sure everything's out. Nope, we have the touch bar cable. That is hiding under here. Alright, I'm not going to worry about screwing down anything right now. Really the main things that I want connected are going to be the USB-C, the mouse trackpad, or trackpad keyboard, maybe touch bar, why not? We're already at it. I won't worry about the speakers at this moment. And we won't worry about Wi-Fi. And let's actually just put one T5 in here, just so that the board doesn't fall out when we lift it up. Let's see if we have any change. Probably not, just because, as mentioned before by Yummy Steak, this issue was happening which led the customer to open up the computer, but we want to make sure that we resolve that damage before we go any further. Okay, so we're getting power. We got 20 volts at 800 milliamps. I'm just going to hold option down real quick. Kind of see if we Can option boot. Alright, backlight just turned on. Alright, so at this point it's not detecting an SSD. Well, I should say it's not detecting anything on here. Let's go ahead and boot into an external drive just to confirm if the SSD is even present. Because the silly thing is, and just want to rule out, is that the macOS operating system is not just corrupted. Now, actually, let me restart this whole procedure. I'll actually go ahead and plug back in the battery. There's a thermal sensor, I believe, built into the battery connection. And being that we're messing with a thermal sensor, I want to make sure that that all the temperatures are reading like they should. And so if we put this all back together and then all of a sudden the fans are still running at full speed, then that means our pin 4 on our U5860 is not properly soldered on, so it's not properly working. So it goes into a fail-safe and just thinks that everything is jacked up all the way. Or it thinks that the computer's on fire, so it jacks up the fan all the way. So, got to do process of elimination, but we want to have as little variables as possible. Alright, now that everything is put back together other than the Wi-Fi antennas, let's see what happens when we option boot into a install of Test Catalina. Alright, let's turn off the fume extractor just to hear if the fan's running high. Yeah, it sounds like the fan's still running a little high, so it looks like that Thunderbolt thermal sensor is probably still damaged. And if I had to assume, it's going to be pin 4. Let's actually give it a PRAM reset after doing that. Oops, wrong key. Oh wait, now we have an Apple logo. I think that's because we're booting into our drive. Let me interrupt this one more time. I didn't do the PRAM correctly. I wasn't holding down Command. Alright, the fans are still running pretty high. So at this point, I'm going to say that we still have an issue with our U5860. But let's try to see any second now with option boot if we can actually boot into a test drive to see if it even detects the internal SSD. Alright, so let's boot into a test Catalina and just let that load for a minute. Yeah, you can really hear the fans going now. So because we have that issue, the CPU is throttling itself since we're having that thermal issue. And because of that, this is actually going to take quite a while to load. So let's go back here to our board view and try to figure out how we're going to fix this. Yeah, so it looks like it's just this component, and we're going to have to wrap it all the way around here. Okay. Yeah, so it's really struggling, really taking its time. And again, that's just because when the thermal sensor is missing, the CPU will purposely underclock itself or throttle itself so it doesn't kill itself, and the fan runs at full speed to keep the computer cool. Well, when the CPU underclocks itself, it in turn is going to run slow. And this is all going to be more than likely attributed to the fact that our Thunderbolt thermal sensor looks to be damaged pretty severely. Okay, we're almost there. And it's almost there, that last little bit. You can do a little MacBook. Alright, we got a beach ball. Start by confirming it's actually that and not something else causing the fans to go bananas. Continuity measurement to where it's supposed to go. Your work looked just fine to me. Yeah, what I was thinking about doing next is soldering a jumper wire onto the other side of the board, specifically that resistor. Let's see what resistor it was. R5861, and just kind of have it hanging over the edge of the board. That way I can then take my multimeter with the wire kind of exposed and test for continuity on the wire as well as on pin 4. And if it's not present, then that will just kind of confirm that this is missing. So that'll be the next step. I'm just kind of at this point, curious to see what's going on with the SSD. But that's a very good suggestion. We have a cursor, but nothing else. Just because it's still throttled at the moment. Oh no, I think it just booted into reset password mode, which takes forever to boot back into normal mode. Okay. Nope, this is actually something else. I forget about this specific issue, and Chris at Shiny Computers has mentioned it to me. A critical software update is required for your Mac. Connect to a network to install. Alright, at this point, let's shut down. Before I pull that board out, I actually just want to check one other thing. I'm going to go over to logi.wiki, hosted by Chris at Shiny Computers, and check the information regarding that specific update. Because I know that's kind of open-ended, and what we're working on can kind of be one of the reasons why it's not working, but I need to see what I'm dealing with real quick. Alright, so let's pull this up over here. So what we want to do is go to logi.wiki. And I'm pretty sure there's this whole section on here talking about the critical update. Critical update required and critical update required troubleshooting. Let's see what's going on here. Critical update require error message can appear when either Bridge OS is corrupt or if there is a hardware fault that affects Bridge OS. Troubleshooting this error is difficult, however, the following steps below help isolate. Boot into safe mode, create time machine, make sure lifeboat connector is on, boot into no good compatible OS. I mean, I'm sure all this is going to be kind of a symptom of our larger issue. Boot into bare board with known good USB-C. Check all data lines. Check all data lines, power lines of NAND, which is exactly what we're kind of messing around with. So that could definitely be one of the reasons why we're popping up that error message. And I actually haven't looked at this section yet. Critical update required troubleshooting. This is not the same thing that we just talked about. Troubleshooting this error is difficult. Follow the steps below. Boot into safe mode. Okay, we've already done all that. Check all power lines. Okay. It kind of gives me more of an idea of what we're looking at. Okay, I'm still just kind of waiting for this computer to turn on. In the meantime, let's see. PP1V8 SSD cold was where we were missing some power, and that power is going to be coming out of our U9300, which is our piccolo. Good job, Tim. That's awesome. Now, when you replace the BIOS, did you also replace the serial number? I'll be right back. I gotta go get a drink of water. Alright, let's see where we're at with this one. So what I decided to do instead was, instead of booting into a test Catalina, I was just booting into a test High Sierra. Interesting. So having a bad BIOS or a corrupted chip was preventing you from doing a PRAM reset. Interesting. I'm not sure if you had to replace the ME region on a Core 2 Duo processor. I feel like it's still necessary, but on a unit that old, I'm not sure. Alright, let's see where the computer's at. Screen looks like it went black. Okay, and the computer as a whole looks like it just stopped. So at this point, let's go ahead and check and see if we have continuity on pin 1. I'm sorry, not pin 1, pin 4. Check and see if we have continuity on our pin 4 to the other side of the board where that resistor was. So in order to figure out what is going on? We have to fix our throttling issue, which is caused from this temperature sensor being messed up. But also, being that it's going to that update required mode, kind of tells me that there's something else, probably with the power of the NAND, that is messed up. I remember one time I had a computer that kept getting the error message that an update was required, and it turned out to be that there was an issue with their touch bar. But it was pretty apparent. When we pulled it out, there was a cut where it looked like he dropped it. Somehow some pressure pushed a standoff into the logic board, which then cut the flex cable. So that one was a little easier to troubleshoot. Okay, now to test to see if we have continuity. Alright, so let's see exactly where that resistor is. So here on pin 4, goes over, okay, it's above this NAND, it's over here. Okay, I think I see it. I do. So, I'm just going to temporarily run a wire, just so that I don't have to hold the board up sideways to test this. Come on. Don't die on me. Don't want that touching anything. Alright. Flip the board over. You're not going to temp paint on clearing the ME region or not clearing the ME region? It's working, that's what counts. LOL. I know there's a big issue with the I series that if you don't clear the ME region, then it is going to throttle itself. However, this might be dumb, I I don't know exactly if the ME region's stored on the processor of the Core 2 Duo or if it's on the MPC or the PCH. That is a Piernoff question. Again, I don't really work on that model anymore, so I don't know. Okay. So I got a wire that's wrapping around the board, and I just went ahead and tinned it up so that I can probe it with my multimeter. Now what I see is going to be tricky is getting under pin 4. Although I don't necessarily have to get under it, I can actually just kind of poke the side. Let me try angling this up. According to forums, these don't have ME regions. That's kind of what I'm thinking with the Core 2 Duo. I think that was introduced in the I series. I think anything to do with the ME region was all handled by either the separate PCH, which they integrated into the I series, and the, what was it called? The MPC? MCH? MPH? Once again, I'm actually not that familiar with those models. When I was fixing those models, I wasn't doing board repair. If I change the serial number, I run the risk of messing up checksum. There's actually some really neat programs out there that help you change the serial number. Okay, so I think if we expose this part right here, I can kind of probe it. And let's see if we can kind of just tuck that under there for the time being. Alright, so if MCP, thank you. I knew I was saying it wrong. Cool, we have continuity, which means we might have an issue elsewhere, or something else is not properly soldered on. Cool. I actually feel good knowing that that tiny little coil that we wrapped around on our pin 4 works. Yeah, I have a Medusa programmer that I use for newer machines. Use JTAG as an interface. That's awesome. I've actually never thought about getting a Medusa just because of the price. Can't say I do enough BIOS swap or BIOS repairs here, but it is a handy tool to have. Let me switch out my tips, because this one's kind of a fat tip while this one's a skinny tip. It almost looks like this one is not on. This one is on, so maybe this pad is the reason that's not working. Okay. Now let's check for this side. That one is good. Alright, so we're going to have to touch this one up. Let's go ahead and take care of that real quick. Yeah, I think the Medusa is like 300 USD. There was one iMac that I could have benefited from having the Medusa. Pradeep PR says, "Hi bro, how are you?" I'm doing well, how are you? I'm tired, but I'm doing okay. I'm alive, I got my health. Doing all right. Alright, that looks like a better connection. I'm glad to hear that. I'm glad that you're fine. There's too much negativity in this world. I do love my toys. I bought extra connectors too at $45. Oh, each. Ooh, that can get expensive. Yeah, and if you're doing a lot of BIOS repairs, that makes sense. I haven't had to do enough yet. How's the virus situation there? It's actually... it's not as bad as some places. It's not good. We're not as bad as California. I actually checked it the other day. And I think my state in the United States has about 200,000 cases, confirmed cases. I think California had some ridiculous number. Like, I've known people that have gotten the virus, and they've gotten sick from it. But I don't know, a lot of people have gotten it, so it's not horrible, but you know, it is something still to be cautious about. I almost feel like a lot of people are moving here. Oh, 6 a.m. here, time for me to start my day. We'll finish the stream later, gotta run. Hope it's easy as possible. Random cap short. Thank you so much. I greatly appreciate all your feedback, Yummy Steak, and I hope you enjoy the rest of your day. Thanks for enjoying your morning with me. I'm sorry I wasn't fast enough. Alright, so I almost feel like these aren't properly touching like they should. Alright, so that one looks okay. That one can be touched up. I don't even know if this one's touching. No. Okay, so if I had to assume these actually aren't soldered on that great. So we're going to fix that. We're just going to expose. I think what happened is the masking was too much, that it actually covered some of the metal on the trace, some of the copper, preventing it from properly soldering on. That would be nice. That way we can at least take care of the user damage and then move on to the real repair. Alright, so let's check and see if we have continuity on that pin. Sweet. Looks good. That one looks suspicious. Yeah, okay. So it looks like we still need to take care of that pin. I'm a beginner for MacBook repair. Logic board repair from India. That's awesome. Okay, too much mask here. Love to see what you're doing in feature. I'm assuming that's future. Please live stream MacBook Air repairs. I actually had a MacBook Air repair yesterday, which took way too long. I didn't do a live stream on it, so I did fail in that regards. But I do have an A1923 in queue to be worked on. But I don't really have too many A1466 customer related boards. I do have a couple of refurbished computers with A1466 boards. So yeah, I'll try to make that a point. That's actually the most That's one of my favorite ones to work on. I've fixed plenty of those in the past. Like, if you're getting into board repair, I think starting on the A1466 MacBook Airs, like 2013 to 17, is a good range to begin with. Alright, so we have all of our connections back. Let's put this back into the housing and see if it's going to actually turn on. Well, I should say if it's going to turn on without overheating. Oh, before we do that, actually, let me remove this jumper wire that I installed. We don't want that just hanging out. Let's remove you. Awesome. Alright, let's grab our housing and start putting this back together. But yeah, Tim, there's this one tool that I've actually used on Mac. I think it's called, like, just EFI tool. Something generic like that. But you can actually just change the serial number from there and it should fix that checksum. But being that it's a 2009, it's probably not worth doing all that, because it'd be the equivalent of just putting a new logic board in there anyways. Which, like you said yourself, that was an $80 board. So, if everything works, and I can't think of any reason, but also there's no research as to say why you should worry about replacing the serial number on a Core 2 Duo machine, I would say that was a successful repair, especially if it's something that you normally don't work on. Sorry just today I came across your channel recommendations. I'm your subscriber now. Haha, thank you. Yeah, I really just like to stream just for educational purposes. I like to be able to actually upload my videos, because when I upload, the uploads definitely get a lot more views than my streams. I think YouTube's algorithm will only show a stream for so long. And versus with a uploaded video, you'll probably get recommended or featured in other videos. Like, we have one video on here that has the most, right now, has the most views, and it's how to replace an iMac GPU. That's actually a video I did a while ago. I did it last September. And for some reason, it just started blowing up. So I haven't checked, but the last I checked, I think it was around 5,000 views. Versus when I do a live stream, I think the most I've gone for a live stream was about 100 to 120 views. But the interesting thing with that video is, like I said, I made it back last September, and about a year later, it just started blowing up. But no, I like streaming. I do it. It's therapeutic. I like being able to go back and see if there was something I missed, or I can give the stream to a customer to show them that their board was repaired. But if you like my videos, you should go check out Optimized Logic Repair. He's here in the chat. He's also got some good videos too. He's smarter than me too. What's your name? My name is Esteban. It is Spanish for Steven. I'm as pale as it looks, but I am Costa Rican. Alright, let's see if we now get any weird fan noise. Estatron, you understand. You definitely know. Estatron. That was an old nickname at a former employment endeavor. Alright. So far, so good with the fan. Let's let it rev up for a little bit. Meanwhile, let's go ahead and boot into like a test High Sierra. In fact, let me actually turn off my fume extractor so we can hear the fan. Fans are starting to rev. Nope, looks like we still have an issue here. Alright, let's give it a PRAM reset. Where did you learn MacBook logic board repairs? This sounds very poor, but honestly, from having a whole bunch of boards here that I couldn't fix at the time, I had to end up replacing the logic boards. So with the spare donor boards I had, just from being on the Rossmann forum for board repair, and of course watching Louis Rossmann's videos, I learned the fundamentals for board repair, and then actually having practice allowed me to learn everything that I know. And I'm still learning. I'm still pretty dumb when it comes to this stuff. Alright, so our Thunderbolt thermal sensor is still going. Or the fans, I should say, are still revving high. Oh, man. Okay. So we can't even get to testing the SSD. Then again, kind of like what Yummy Steak was saying, we may still have an issue that's causing the thermal sensors or the fans to run at full speed as well. Okay. And we checked the continuity of our pins. Now, the only thing I could think of is that there's one pin that's missing in particular that I wasn't able to verify if it was actually soldered on or not. That pin could be messed up, so we can try putting that back on. And if it still doesn't work, then we're going to have to troubleshoot elsewhere to see if there might be another reason why this isn't properly not thermal throttling, so that's actually detecting the thermal sensors like it should, because there could still be another issue here. Once again, this one is in here for an SSD repair. It's not detecting the SSD, but we have an issue where we're having to repair where ripped traces were before we can even get to the true troubleshooting process. FYI, you don't need to remove RAM on these to do a PRAM. No, the only reason I recommended doing that was it helps your EFI process. With the Core 2 Duos, you can do some things by removing the RAM. I won't go into too much detail. All right, let's check and see what's going on here again. Alright, so I think the pin on the far right is not properly connected. And the only way for us to actually test is we're going to have to expose the copper a little bit. And then put our multimeter into continuity mode. Continuity mode is when you hear the beep, there is a solid connection between the two different probe points. So if we put where our wire is supposed to be right here, and then we probe, we're solid. So we're actually perfectly fine. Here we're solid. I think this might be where my issue's still at. Oh, these traces, they are going to be the death of me. Okay, so we should be able to touch a pad here and here. And then this is ground, this is ground. We've already made sure that this has continuity on the other side. And then we've made sure that these are properly touching. Oh, did this one change? No, that one is working like it should. That one's fine. Are any of these bridged underneath? Doesn't seem like it. Okay, so we may have another issue here. I should say we definitely have another issue here, but we need to find where said issue is at. Okay. Okay. Let's check and see if we are getting voltage now on that capacitor for the 1V8 SSD cold line. So let's hook our power supply back up and see what we're getting. Staying at 0 volts. Let's see if it's going to spike at all. Okay, nothing at all. Let's see what else. Let's check out our board view again. This is going to be one where we have to think. Alright, PP1V8 SSD cold. PDPV IOE SSD clock. Let's see where else you are. Okay, so it looks like that it is connected to this bidirectional line that connects to S3X PCI clock required low, which is part of our, if I had to assume this is our main processor. Nope, it's just part of a NAND. Okay, and that actually is part of the NAND directly to where our power's at, the PP1V8 SSD cold. Okay. Alright, so this is a smoothing cap, and that was the smoothing cap that was missing. It comes after a coil, which comes from P1V8 cold switch 0. And it looks like they're actually daisy chained together, so that means we're also missing P1V8 cold switch S1 and feedback. Let's check and see if this feedback line's here. That's going to be on the other side where U9300's at, or PMIC. Okay, so now we got to pull the board back out. This one definitely is different. Because most of the times we just have either liquid damage or straight a board issue that's not working. But when you add some other unintentional damage into the mix, it's kind of hard to figure out if that's even our issue or if it's related to our issue. Come on home, bud. Don't get stuck there. Oh my goodness, it's already 12:30 over here. So this stream has been going on for a while now. Yep, 3 hours. 3 hours and no headway. For those of you who've been watching, I appreciate your patience with me while we try to troubleshoot this difficult one. I am looking forward to this one working though. Alright, so what I want to do is take my donor board, which is missing its sensor that we stole, to see if this is actually going, with a missing Thunderbolt thermal sensor, if this is still going to generate our 1.8 volts needed on that 1V8 SSD cold line. What do we have? Alright, so computer is turning on. And we are missing that 1.8 volt line, which means that's probably fine. What's the temperature you keep your soldering iron on? My soldering iron is probably too hot, to be honest, but I have mine set at 400 Celsius. At least I think it's Celsius. I don't know. 400 Celsius seems about right. Because most solder that we have here melts around 380 degrees Celsius. Alright, so that looks like that's actually normal to be missing that line. Unless this board also has another issue, similar to what we currently have. So let's not go down that rabbit hole. Let's kind of figure out what else could be going on. Oh, hey, hold on. Oh my god. That is a hole. That is an actual hole, or it's a bubble. It's about to turn into a hole. I think this is going to be where our issue's at. What is this? What is this? This is the eureka moment I've been looking for. I just needed to use my eyes a little bit longer. All right, so this test point right oh no. That would make a lot of sense. PP2V7 NAND VCC. That is going to be a 2.7 volt line that powers our NAND. In fact, let's actually check and see what this is. U9400 is what it connects to. I think we may have found a issue. So let's full screen this real quick. So SSD NAND VR. Don't know what the VR stands for, but judging at the end of this circuit, PP3V3 underscore T2V7 NAND VCC, this is going to be a power rail that fluctuates between 3.3 and 2.7. That's how I'm interpreting it. And in order for it to be present, we need to have PP5VS4 P2V7 NAND LB. So my understanding, and just going off this, if our 5 volt rail is in the S4 state, it is going to trigger the 2.7 volt power necessary, which should still be 5 volts, to turn on U9400. Let's check and see if we even have that. Oh my god, I've wasted so much time. But at least we've made some progress. Should have just looked around the board a little bit longer. Okay, let's see. Find your happy place. So I'm going to measure that test point. That looks like it melted. It looks like maybe there's an internal short. So if we touch, we're getting our 5 volts. But this pad, what is this trace supposed to be? Let's poke it. 3.3. Let's make sure that that's right. Hey, you learned something, right? I learned... What have I learned? I guess you could say that I've learned that you can apply iPhone repair techniques to a MacBook. I also learned that PP1V8 SSD cold is not present whenever the computer is turning on. I think that's about as much as I learned. Okay, let's see. I like the optimism, though. Oh yeah, that's right. We were going back here. Okay, so we want to go back to our board view and check and see what this connects to. All right, it connects to this capacitor. And this connects over here. So this is a 3.3 volt line. And this is going to be our 5. Hold on. Because it was reading 5 volts, but it says the voltage is actually 2.7. How would it be 2.7? If this is a 5 volt line, let's check our 9401. Our 9401 is right above our U9400. Okay. Optimize logic repair. It's in my name. You're not wrong. And oh, I apologize. I'll be right back. Alright, I'm back. Alright. So, the schematic says that we're supposed to have 2.7 volts. I don't know if that's the minimum and it fluctuates if it's a 5-volt line. But I'm going to check with our donor board, which coincidentally has had some flux around the same area. And let's check and see what our voltage is supposed to be. Okay, yeah, we're supposed to get 5 volts there, so that's fine. Okay, so that's matching the same voltage measurements I'm getting. So it looks like there was a tiny, tiny drop of liquid damage. Looks like that's kind of where our issue is stemming from. It may have came from underneath the trackpad, but somehow, and you can barely see it, it's a little bit of corrosion built up right here. And it got to the point that it's actually swelled up this part of the board. Let me check on the other side and see what's up. Nothing obvious over here. Okay, so all of it looks to be about right here. So why would this happen? I mean, it's got to be sending too much power somewhere causing this to swell up like this. Okay. What else are you responsible for? So you're responsible for, let's see, we have an enable. Let's check and see if we're even getting this power. VP3V3 underscore 2V7 NAND. Looks like that's on to the left side of these giant capacitors. Okay, so these giant capacitors to the left. Let's see what power it's putting out. Alright, it's power cycling. Is it? Or are my probes just dirty? No, it looks like it powered cycled there for a minute. Let me restart that again. Nope, we are just staying at 0, which means that either there is some short here or U9400 is not working. So let's check and see what our resistance is. There is no short to ground there, so that doesn't look to be our issue, which means that a U9400 is probably not being told to turn on. Let's check the enable pin and see if it's working. We don't want to just replace a chip. We want to make sure the chip is even being told to turn on. So if we look right here on U9400, we can see this in for enable is going to come from Piccolo Vin 1. So let's check and see on R9420 if we have some sort of signal. I don't know what that signal is, but it's going to be more than 0. Alright, I am getting a reading. Actually, no, I wasn't getting any reading. Hold on. Yeah, I'm getting a reading of 0. which means the enable line is not even present. Well, let's check the other side of the resistor just to make sure that resistor isn't bad. Yeah, there is no signal going into the U9400, so it's not getting told to turn on. Just because I'm not really familiar with this specific issue, I am going to compare it to our donor board just to see if it has a similar issue. Now this donor board I know works in safe mode just fine, but it also has an issue whenever it tries to boot normally. So let's check and see. Yeah, we're getting 3.3 volts on our donor board. Aha! We are getting closer to our issue. We do not have an enable signal coming out, which means we need to now trace and see what component enables or sends that enable line. So that is going to come from Piccolo VIN 1. So let's follow this back. And it looks like it's going to come from our Piccolo PMIC. Hopefully that's not bad, because it is a BGA. We can reball if we need to, but I don't want to do that. Alright, so that signal is going to come from U9300. Okay, and in order for that signal to be present, let's see, not connected, Piccolo VIN 2. Let's see here. It looks like there's going to have to be some lines as well. So right here, PP2V7 NAND P good. Assuming this needs to be present before it actually sends out our VIN 1. Either that or this signal is going to come in here after our Piccolo voltage enable 1 is present. Find out. Let's find out. Alright, so let's switch back over. Actually, looking at it, what's probably going on... No, it's too early to tell. But we may have a severed connection between this line and the resistor, just because of where it's starting to bubble up. And the only way for us to figure out if that signal is coming out is if we actually remove the IC. That's not really a good way. Huh. Okay, let's think of a plan B here. How are we going to approach this? How are we going to take care of this? To see if there's a severed connection, I know. Let's use diode mode with our known good, or our donor board I should say, which is partially known good. That circuit's known good, as well as our patient board, and check and see if there's a big difference in diode mode readings. If so, that will kind of tell us if we have a severed connection between the Piccolo IC and the resistor that sends the enable signal to U9400, which will then turn on the 2.7 volts, which then turns on our NAND. Let's find out. Okay, so when measuring in diode mode, you want to reverse your probes and put your red probe on ground and your black probe on your specific area. So this is our patient board, and what I want to check is right here, we're getting a reading about 0.5. Alright, let's go back to our donor board and see what the real rating is supposed to be. One for one, 0.5. So it doesn't look like that we have a severed connection between the resistor and our Piccolo. So now we need to find out, is the Piccolo IC just not being told to properly turn on? And if I had to assume, maybe, once again, assumption, it looks like there's a couple of things going on here, but let's check our P2V7 NAND P good. And that is going to be the resistor to the right. So let's see what kind of frequency we're supposed to get, or voltage we're supposed to get with our donor slash known good board, and we'll compare it. So it looks like it's going to be the top of this resistor. We were supposed to get a measurement of 2.7. Which, if I had to guess, is there because that's what U9400 creates. So maybe the P-good signal will not be present until after it sends the voltage enable line. And this is where things kind of just become a rabbit hole. That was weird. Kind of jumped all over the place for a minute. Now let's just make sure it wasn't a matter of having a dirty probe. Alright, so we're staying at 0. We're not getting 2.7, which is possible because we're not generating power out of U9400. Nope, still staying at 0. Okay, let's see if there is, or what the resistance is on this specific line. Looks good. Not being pulled down. Let's check the diode mode measurement. 0.4 or 0.47 specifically. I bet U9400s are issue here. .8. Close enough. Okay. All this looks the same, but we're not getting the same voltage. So something else has to go into Piccolo in order to send out the enable signal. What is that something? Okay, so these are lines that are going in, and these are lines that are going out. So maybe we have to check and see if there's something going on with like the SMC OB1 or SSD debug. That could also be it. So let's check around. All right. Rabbit hole time. And I'm just going to get a quick measurement of this real fast before I just switch back and forth. Okay, so it looks like the resistor is perfectly fine. SS debug YORT R2D. And there's a no stuff line that's supposed to power, so that's actually just a blank line. PB3V3 underscore 2VC NAND VCC. And we have a pull-up resistor of 1,000 ohms between, or 1,000 kilo ohms. Okay, that's kind of in the same proximity of where we were working on earlier. Okay, 1,000 kilo ohms, so that looks perfectly fine. Actually, as I'm reading the schematic, this line won't even be present because that comes from our U9400. Okay, let's see what else we need to look at. Excuse me. Because see, the Piccolo IC is known for a lot of different things. So we checked earlier, and we did have the PP3v3S5 SSD that was present. Is there any other like enable line-esque lines that are supposed to be present? This line is not created until U9400 is turned on. And we did confirm that PP1v8 SSD cold is not present when the computer is turning on. Or at least we confirmed that with our other MacBook logic board that we had here. Okay, so let's check this. S3X debug art D2R. Where is that line? That line is under U8600 and under U9300. So there's not really a way for us to test that, because these are just direct lines. Well, there's a resistor at least for S3X SMC OOB art, and that's going to come from U8600. And it goes directly to the PMIC. Okay. I feel like I'm starting to go off the rails here. Let's think of the obvious issue. We have apparent damage right here. Something is beginning to swell, and it is separating the board from other layers of the board. When we look over here, let's see what all this is connected to. We have PP2v7 NAND VCC, which is not present. PP3v3S5, which is present. This is supposed to also be PP3v3S5. And what is this? This is just ground. So I almost just want to pop this like a pimple, because this is just a test point that's going to lead to a via. And then we may just have to run a jumper wire right here, but I'm really curious as to what's going on right here. This is going to be your issue. And everything else is just going to be a symptom. Because we could still have a bad Piccolo. So I'm going to do just a little bit of excavating right here. This is exactly how the MacBook that fell into a bathtub stream went, where it made a lot of progress, and then we came to a standstill. And we made a lot of progress, and then we came to another standstill. So these USB-C models just tend to take me a little bit longer to work on. I'm thinking we may have a partial short on our 2.7 volt line. Yeah, if I had to guess, that's what's going on here. We have some sort of partial short between this 2.7 volt line and the ground underneath it. Honestly, I don't even think that we need this connection. And hear me out. The reason why is because if we go back to our schematic here, it's going to go to, let's see, just to double check. This is going to be our PP3B3S5, which isn't really going anywhere else. Then we have this probe point. This probe point is probably touching some sort of partial ground. Let's double check. It's around like 400 kilo ohms as far as impedance goes. I'm sorry, you can't see what I see. I apologize. Alright, so our resistance is in the mega ohms on the known good board. Then when we come back to this board, it's also in the mega ohms. So, let's just remove this trace because it doesn't go anywhere important. Just exposed some fiberglass right here. So we're removing the top layer of the board now. And if I had to assume, this is all ground. But we can confirm that. Just going to expose this a little bit. And then we'll get our multimeter, put in continuity. And what do we have? Alright, that's exactly what that is. So that's ground. Oh, where'd we go? I lost my place. Here we are. Alright, we don't need this trace, so we can just say goodbye. That's something that's there from the development process. It's not actually used on the working board. Alright, in this test point, I'm actually going to remove the top off of this as well, just to kind of expose the via, make sure it's not touching anything else. Okay, afterwards we're going to end up just touching this up with our mask. Okay, now we can actually kind of see where our bubble is, where our hole was. So now I've separated the ground from another layer of the board. Wow. So this is all actually just ground underneath here. This is crazy. I've never seen anything like this. It's just an actual hole. It's just like an air bubble. Alright, so I normally don't dig through people's boards like this. This is not a common thing. But for the sake of science, in trying to figure out what exactly is going on here, we're having to dig and see what is up. Alright, so I'm not seeing anything else here. This all looks like this is ground, and then underneath it is something that's like an insulated layer. But I don't see any other potential damage in this area. So how we got that bubble in the first place, I actually have no idea. That's usually from heat damage. In this case, there may have been a partial short on our NAN. I'm sorry, on our P. Oh my gosh, I'm sorry. I'm getting tired. We may have actually had a partial short on our 2.7 NAN voltage line, since it is right next to ground. Check and see. Yeah, now we're just starting to go into that next layer of fiberglass, which really isn't important. And then we weren't really too concerned about this line right here. That was just a 3.3 volt line that goes nowhere. And right now I'm just trying to make sure that our via is removed from any potential exposed ground. Okay, I think I found our hole. Bam. There it is. Something burned right there. That is definitely why we are having an issue. Something had actually burned a hole in the second layer of the board. Okay, and we've made some progress. Let's peel back this line because we don't want this touching anything. Once again, this line's not being used right now. This is kind of the cul-de-sac of a power line. It's a dead end. Wow. I don't know how this happened. Oh, it's actually going through, it almost looks like it's going through another layer of the board. Yep, it went through a whole nother layer of the board. Wow, okay. So this is definitely going to be why we're having an SSD issue. And this has been a very, very fun one to troubleshoot. Okay, so this is our via. All of this is just ground over here. And I can actually see a trace underneath here, so it looks like maybe that trace. Let's pull this via out. I'm not sure where the via actually goes to, but there's a lot of burn around it, so it looks like my assumptions about there being a partial short might be accurate. So the via has been extracted. Man, it's like extracting a tooth or something. Wow, it just keeps going. Oh my god. I would have never figured this one out with traditional schematics. I'm glad that I actually just kind of stopped with my gut. This one might not be repairable then. Dude, it just keeps going. It's going through another layer. Wow. Alright, so I'm trying to remove the top layer of grounds just so I can expose this. And like I said, I think this is a trace going elsewhere. Holy crap. Okay, so somehow there was a short in the middle layer. It was in the second layer of the board. If I had to guess, it was the test point. I want to know where this trace goes, because I may have damaged it. That's what it looks like. Or maybe it was damage from the short underneath here. This isn't really the easiest thing to just kind of peel back and look underneath the hood. So one thing I really like about ZXW that I really wish there was a way to figure out for MacBooks is it actually tells you the trace location under each layer. It'd be really cool to have something like that for MacBooks, because that would help us figure out exactly where this trace is going and what it belongs to, and if we needed to run a jumper wire elsewhere. Okay, let's kind of clean this up and see what we're looking at now. We just pretty much destroyed or popped the bubble of where all this damage was. Okay, so we have a trace, but I don't know where the trace goes to. I don't know if this was an existing via. Only thing I can think of is probably probing around here in continuity real quick. Okay, what about this? Are you ground? looks like that is ground underneath being exposed, and this is just a burnt up trace. Now we need to figure out where that trace goes. Now that all this has been removed, I just want to see if this is going to do anything now. Let's see what the computer pulls. Still pulling 20 volts at 800 milliamps. Let's check and see if we have those signals coming from Piccolo. So that was, I think, this resistor. Nope, nothing. Nothing there. 5 volts. 4.8 volts. That's a weird frequency or signal. And nothing here. I wonder if this trace that we see is going to be what actually sends the enable line. Let's find out. Let's see what happens when we probe it. It looks like it's too far burnt anyways. Either that or it just doesn't have a signal coming out of it. But we're still not getting an enable signal to turn on U9400. Alright, just to make sure, let's put this back into continuity and check and see if this is shorted. It's not. It just doesn't have any line coming out of it. I'm not even sure what that's used for now. Okay, so at this point we have one or two things that we can do. We can either continue on further and see if there's anything we can do to fix this issue, try to troubleshoot what that pin actually goes to. That might involve actually having to remove our Piccolo PMIC and kind of probing around. Or at this point we just deem it irreparable, because there is a hole in the board. There's obvious signs of liquid damage. There was corrosion there, and something had generated so much heat that it actually burned the inside of the board. It looks like maybe there was a partial short inside of the board, which then caused it to just basically gas up, and we just kind of exploded the pimple. It's a horrible analogy, but we found where our issue lies. At least it's pinpointing in that area. So we need to figure out what we want to do. Do we want to try to continue further? I'm not sure. I'm really not sure what else that could be. Because it's not it's 2.7 NAND VCC. But let's check our enable line. The only other thing I could think of is maybe check to see if diode mode is different. We'd have to remove U9300 and check and see if there's a diode mode that is different. But we'd have to remove every single U9300 or U9300 and measure every single pad, and if everything is okay, then we have to reball it, put it back together. This one is going to be tricky. It almost looks like it's coming from the other side of the board. The interesting thing is that there's no power on that line. I wonder maybe if that's connected to this line right here. Probably not. But let's expose this trace here for a second. Somewhere we obviously have a disconnect now. Yep, looks like that's it. This line right here is actually this line. So let's find out where that goes. This is going to be really hard because the schematic actually doesn't tell us. It does not tell us at all, but at least we kind of know where the trace is. Man, this one really is hard. Okay. Nope. Kind of lost on this one because that probe that I just pointed is right here. So it goes from here and then down. Could it be that it's actually PP3P3 2VC NAN? Only reason I mention that is because it rides up along the side of it. I guess what we could do is inject voltage into it, or not inject voltage, but we can turn on power and then measure that area with our multimeter, although I don't think we got a measurement a second ago. Yeah, we're not getting any measurement out of that because we don't know where it goes, to be honest. But looking at it, you'd almost need an X-ray at this point. It comes through here, comes down, and it turned right. So it looks like, does it connect this? I'm curious, actually, if that's what connects to this component here. What is this? That is, if we pull up our schematic, P2V7 NAND DRVL. I guess what we can do is check the diode measurements. Why would they do that? Why would Apple do this? Okay, let's get a diode measurement and then we'll compare it. Because we might be able to just run a jumper wire if that's the case. 0.43. Okay. .43. Nope, so that's not it. Okay, where else could it go to? Let's figure this out. We really, really need to figure this one out because we're so close. It's got to be one of these that. So let's just get measurements in general. Okay, ground. 0.5. 0.5. OL. 0.5. And let's compare that. Zero 0.5, 0.5, 0.5. The other one we had an OL. Let's go back and compare again. Just to make sure, please still be an OL. What? What's going on here? Like at first I get nothing. I'm still getting 0.5. So maybe that's not the issue. Let's take a look at that real quick just to see what that is. That is P2V7 NAND set 0. But that looks like that's just a line that literally comes out of 8 and then kind of loops back into 9. So I don't think that's going to be our issue. Okay, well, let's compare something else again. We're almost there. We're near the finish line of what's going on. We just need to actually pinpoint where exactly this issue is. Okay. 0.4. 0.57. 0.3. 0.5. 4.7, 0.5. Zero 4, 5.7, 0.3, 0.5, 0.5, 0.5.2. That's just 0.3. And 0.36. 0.57, 0.36. Zero 0.57, 0.3. So we have a difference right here. All right, let's keep looking though. 0.43. That looks interesting. Zero 0.43. Okay, that actually I guess is normal. 0.4. 0.4. Okay. And then let me just check these last two, and then we'll move forward onto that one pin that was a little suspicious. 0.5. OL. Zero 0.5. 0.5. All right, let's double check that again just to make sure that I'm not trolling myself. I was trolling myself. This is why I ordered new probes. 0.5. Okay, so the main difference I'm finding here is this component. I'm getting 0.3, but on the other one, I'm getting 0.36, I believe. Let's double check again, because that's all we're going to keep doing is just double checking. Yep, 0.36. So, we definitely have something else. It's resistance on that specific line. What is that line responsible for? That is P2V7NANLL, also part of the Boost RC. Actually not sure what that is, but let's see. Alright, so one side is going to be boot, the other side is going to be phase. There shouldn't be anything else though in between. So pin 16 to pin 18. There really shouldn't be anything between pin 16 and pin 18, unless this goes elsewhere. Alright, yeah, for you that have watching, thank you so much. I appreciate your diligence with me while I try to figure out exactly what's going on. This one is not an ordinary issue. So, thank you so much while we take this journey together. These are the kind of repairs that I'm going to have to give myself a time limit for. So what I'm going to do here is expose a little bit of the copper. I'm going to see if there's any continuity between this part and this part. No trolling. Come on. I think I found it. Alright, so this line actually goes directly here. Okay, okay. I think that's progress. Let's find out what's going on. Oh wow, all goes. Good. Let's double check and see now if there's continuity between here and here. There's not. Awesome. We found our issue. We're going to need to run a jumper wire. Let's see exactly what that is. So that is going to be PPV in. You gotta be kidding me. That's the voltage in. What? No way. Hold on. It is. Hold on. Alright. PPVN 2.7 NAND logic board comes through here, but then there's also a part that goes to Q9401. We know there's continuity between C94 and then whatever we just touched. So let's check pin 1. Well, no, there'll still be continuity on that side. That doesn't really matter. Well, let's check on the one where it's ripped to see if there's continuity between what we touched and Q9401. In fact, that's probably what that trace is it connects Q9401 directly to, I guarantee that's what it is, to that specific capacitor. Alright, so Q9401 is this guy. Alright, and it is pin 1. Let's check that again. Where's pin 1 located? Pin 1 is in the bottom right. Okay, so what it looks like here is that voltage in for here is going to be, I'm just trying to see if I can understand this circuit with my half-fried brain. Let's check and see if it's torn here and here. This is going to be a little tricky, so let me see if I can do this while sideways. Okay, so it's this capacitor and this capacitor. Okay, so that's probably severed. Now let's check this to our known good board and check and see if it's the same thing. Alright, so it's this capacitor here and this. Yeah, hold on, this is actually really hard, really hard. Okay, no, I was looking at it backwards. Okay, so we touch this capacitor and then we touch this side. We have continuity. Okay, that's what it's supposed to have. Alright, so let's try this on our patient board. Touch here. We have continuity. Alright, I think I know where our issue is. So, if we go back here to our schematic, we can see that when we have continuity, hold on, let me take this a step back. We have a hole. Let's start with that. Let's start with our hole. So we have a hole right here in our logic board, if I actually have the right camera. And what's going on is there is a disconnect between this capacitor and this line. Now this capacitor is going to be what actually sends power to turning on a Q9401. If we go back to our schematic, we'll see that there's a disconnect between PPVN 2V7NAND LB and there's a disconnect between PPVN 2V7NAND LB and C9401. We have confirmed that. So there is a sever probably right here that is just completely gone. And what that is, it looks like this is voltage in for 2.7 NAND, which is going to turn on this MOSFET, Q9401. And this MOSFET, if I had to assume, is also going to be responsible for turning on the rest of our machine. As to why our enable line is missing, we're going to take care of this first. We're going to run a jumper wire from PPVN_2VC_NAND_LB to C9401 and resolve this. Before we do that, I need to document this repair real quick and take photos because I have never ran into this situation before. So things are going to be a little bit boring here for a second while I take care of that. So let me do that real quick. Alright, let's take a photo of this real fast. And let's get this in focus. Alright, now that we have that documented and photos taken, let's go ahead and kind of manscape the area. So what we want to do is kind of remove all of this excess ground that's not supposed to be just kind of hanging around. Gonna make it smoother. Oh, okay. I think we just severed our ground connection actually by doing that. Let's double check. So this is ground, that's ground. Nope, looks like it's still pretty good. Okay. So now that we found this hole, we found exactly what it connects to. I think before we fill it in, what we should go ahead and do is just run a jumper wire from this test point to here and see if that resolves our issue. And if it does, then we'll go ahead and we'll fill this in and make a more permanent solution for this jumper wire. Jumper wires galore on this model. Alright, let's turn on our fume extractor. And we're just going to get a temporary jumper wire on here, just enough to make sure that this works before we actually fill in the hole. And I'm going to go around the hole that we made, because I don't want to touch any of that ground. Okay, that should be enough for now, just to make sure and see if the SSD is probably going to turn on. I'm still hoping after all this we are going to have our working fan, because I spent a lot of time running those jumper wires. Okay, let's run some voltage and see if we have 2.7 volts right now on U9400. Alright, we have power hooked up. We have 20 volts and 900 milliamps, which is a little bit more, which tells me that something's turning on. Alright, and what we want to measure is to see, do we have 2.7? We have 3.3. Hold on, let's try that one more time. Okay, what do we got? 2.7, 3.3. That's the reason why this wasn't turning on. Alright, now let's go ahead and partially put the board back together and just make sure that it actually is going to detect an SSD after this. You know, I was a little nervous to excavate this model, but didn't really have much more to lose. I mean, it's either that or the entire logic board was deemed irreparable. So I'm glad we took a chance, and it looks like it worked in the customer's favor. But we will find out more once we finish reassembling everything. Hopefully this resolves the fan issue as well. It's always a little bit of liquid damage somewhere. And this is the tiniest amount, but it was in the right spot for too long of a period that it just kind of baked itself away. It baked the trace away that connects. It was almost like a reference line. I need to go back and kind of study why that line was preventing the computer from turning on. Alright, don't really care about speakers right now. Just care about charge port, power, display, trackpad, keyboard, pretty much everything but the speakers right now. Getting excited. You and me both. I was starting to get a little worried about this one. Yeah, I've seen plenty of videos where people have had to actually kind of go through where the board looked damaged, but I've never actually taken upon myself to do that. So this is definitely is something new for me. How long are we in this stream? 4 hours and 30 minutes. One of my longest streams. One of my longest repairs. Okay. Let's go ahead and turn it on. That's already turning on, so let's option boot. Okay. Now, I expect there to not be anything, so I'm gonna... there goes the fans. So we still have a fan issue, but that's a secondary issue. Let's see if we can actually boot into a test drive. We probably still have to address the fan issue, just because it's going to throttle the CPU. There it goes. We can see it's slowly loading now. Mm-hmm. Okay. Let's see if we can boot into... Let's see, what are we going to do? Let's do like a test Mojave. Yeah, the CPU is definitely getting throttled now. Oh, this is miserable. Oh, come on. Yeah, fans are at full speed now. And since the CPU is throttled, I'm going to let this kind of take its time. Meanwhile, let's kind of look back and see what's going on with the thermal sensor. All right, U5860. Okay, so that is going to be a data line. It communicates to the SMC, to a temperature sensor. It just says X100 temp. Trackpad is in fact connected. Thunderbolt airflow left, Thunderbolt airflow right. So we addressed the right. Is there something messed up on the left as well? We also could have an issue too with these resistors, since this was ripped off. Probably not. They look to be in a pretty safe spot. Same thing over here. Looks like it's right above the SMC. Okay. Alright, so we have some bidirectional lines. RIO, Thunderbolt thermal sensor, D1P. If I had to guess, data positive, data negative. Yep, data positive, data negative. And then our bidirectional lines for SMC, so we may actually have to get our oscilloscope and check and see if there's any data lines actually communicating, as well as check and see pin 7, pin 4. Yeah, this was the one I was worried about. Thunderbolt sensor thermal TL. What does this do? Alright, that's going to go through a 100 ohm resistor that goes to this thermal alert, which then sends to the SMC sensor alert. We could still have an issue here. And the screen is still turning on. More resistors on the back of the SMC. And that's it. So we probably still have an issue here with 5860. I can almost guarantee, since we're having a thermal issue and the fans are running really, really high. Alright, let's go back to our screen. I'm going to go ahead and get some water while waiting for the screen to turn on. Okay, where are we? It's almost there. Come on, MacBook. You can do it. Alright, we have a cursor in the top left. This is painfully slow. Come on, Mojave. I just want to make sure that the SSD is working. That way we know that we've resolved that issue and we can move further into the thermal sensor issue. That's all I want. Come on, you can do it. This is very anticlimactic. It's going to go into critical update mode. So this isn't going to tell us right off the bat if that fixed the storage issue or not, because we still need to address the thermal sensor issue now. Oh, sad. Okay. So we have to address the thermal sensor issue before we can even find out if we just fixed our SSD. Looking at it, to me it looks like we fixed our SSD. It's getting power. But we still have this thermal sensor issue. So I think we need to look around other parts of the board, because if there was damage to the thermal sensor on the left side, maybe there's some on the right side as well. Either that or, I mean, there's that rare chance. I mean, I'm not perfect, but maybe those solder points, or the solder wires, the jumpers I did actually pop off. Alright, let's take another look. I'm just as eager as you guys are to have this one done. Okay, so let's go back in this vicinity. Nothing immediately. I don't even, let's see, it looks like that's the thermal sensor for this model, or for this side. It's going to be something else. Something else that's going to jump out at me. Okay, I think it might be oscilloscope time. Alright, let me pull out my probes for my oscilloscope, and we're just going to have to probe and make sure that these lines, these signals are even coming up. Because this is the last thing that we need to fix. And we can go back on our way with life. Just making sure there's no other damage. But yeah, it looks like that was all the damage right here. I'm hoping it's grounded properly. Okay, yeah, it is properly grounded. Just making sure. All right. So we're going to be looking at U5860 and see if it's properly communicating. And to do that, we're going to be using our oscilloscope. We don't really use the oscilloscope too often, but in desperate times, we do use the oscilloscope. You can't really see it, but I have it right here. So you're just going to have to trust my readings. Okay, we are getting a pretty consistent signal out of here. Doesn't look like we're really getting much out of here. What is that? Actually, it looks like the computer's not turning on anymore. 1 second. What's going on here? Okay, there we go. It's turning on now. I don't think it liked it when I touched that thermal sensor. Oh yeah, it really doesn't like that thermal sensor. It turns itself off whenever I probe that. One second. What's going on here? Let me check with just a normal multimeter, but this is going to be our pin 1, which is our 3.3 volt line. And every time I was touching it with the oscilloscope, it was actually, I think it was shorting out PB3B3 and shutting off the entire computer. So if we put our multimeter into reading, yeah, it drops immediately. Okay, what's going on here? Why is that happening? I don't think that's normal. Let's see, it's a... I actually have no idea what's going on here. R5860 is a 0 ohm resistor. And I have confirmed that is a 0 ohm resistor. What is the resistance to ground? It's in the kilo ohms. That sounds pretty normal to me. Why is it whenever it gets probed, it just randomly dies? I don't have an answer for that. Yeah, it's at 3.3, perfectly fine. Yeah, every time I probe something around here, the computer itself just shuts off. It looks like it doesn't like anything messing with it. But when I touch this side, we're all over the place, but we're not really getting a response over here. Okay. And that's a capacitor. It's a data line, too. Ah, maybe this one's not properly connected. Okay, hold on. Let's check this out. C5861. C5861 is going to connect pin 3 to 2. It separates them. And pin 2, we definitely have communication. Pin 3, we don't. And let's see. It looks like under pin 3, it goes to... I have no idea where it goes to. Just kind of goes over here onto this part of the board. That's weird. Because it's a data negative line. Let's see. Maybe when your probe... Sorry, I can't read right now. Maybe when you probe it, you are changing the resistance. That's the only thing I can think of. It's okay for a split second. But one thing I'm finding a little odd. Let's see. One thing that I'm finding odd is that we definitely have some communication right here on our RIO Thunderbolt Thermal Sensor D1P, but we don't really have anything coming out of our N. Now, is that because N is actually negative or it's ground? Let's see. Yes, actually, it looks like this side might be grounded. Either that or I've bridged a connection somewhere. Let's compare to our donor board. My brain's starting to hurt. With everything that we've gone through this evening, my brain really hurts. I just want to have a working thermal sensor. That's it. I've already did the board repair. Nothing else seems to be working yet. Okay, let's see. Is this actually ground? Simple as that. It is. Alright, so that's perfectly normal. So I guess another question would be, if I accidentally bridged my pin 3 and my pin 4 together. Show me a beep. I still think it's pin 4. Even though we ran that jumper wire. I don't know. I'm about to open up A1707 liquid damage. You got it, man. I know you can do it. I am slowly falling asleep. Okay, but let's see. Let me take another look at this at an angle. Yeah, I mean, that looks like a pretty bona fide connection. Those pins look okay except for ground. What if the not connected was the most important part? Nah. Or is it still this pin? Oh, my eyes just got really heavy. Let's see. Where is this? Okay, that side looks like it's properly soldered on. Hmm. There could be also another thermal issue. Let's see. So we were in the process of testing these out. D1 is not supposed to have anything and not connected. That's fine. A0 is ground, confirmed. Let's look at 4789. Okay. So let's start with 7. 7's going to be this one. Interesting. This one is 19 volts, 3 amps with a battery plugged in. Voltage, 0 amps without. 5 volts, 0 voltage. I too capitalized numbers. I'm glad you do that as well. My brain hurts too much to think about that one right now. The last computer I had that was doing that exact same thing, it was a bad CD3215. Alright, that's weird. So, 7 is supposed to be... alright. Thunderbolt Sensor Alert TL. So I'm assuming whenever this line is low, then it's going to send an alert basically saying, hey, I'm on fire, like, fix things. So there looks like there's a pull-up resistor. Yeah, in pin 4. Okay, so there's a pull-up resistor right here. That's supposed to help with the power, and it is R5862. My bad, this one is not liquid damaged. Oh, okay. Hopefully, it's just something like a shorted PP bus. And that's on the other side. If I had to assume, this QFN is going to... It looks like it has these data lines. We're just going to say this is what's helping with the temperature sensor. Thunderbolt thermal sensor, thermal TL. I don't know what the T stands for. Thunderbolt sensor, Thunderbolt thermal sensor, thermal, low, and then this is the alert. So this is low. This is in fact low. And we can check to see if this resistor is there. But it looks like this, for some reason, is dropping in voltage, which tells me it's getting a signal somewhere else that it's bad. And I don't know if that's going to be the data lines right here, D1 and or D positive, D negative. Excuse me. Okay. Or if it's going to be something to do with this. There's not even a model number on this chip. Well, kind of. Let's see if we can get any information on this chip. Just see how it works. I don't think it's bad. I still think it's D4, or the fourth pin. Oh man, I'm really yawning now. High accuracy, remote, and local temperature. Texas Instruments. Come on. Can you see what I see? Oh, right. Remote diode temperature sensor accuracy, local temperature sensor. Okay, that's fine. Description: device is a high accuracy, low power remote temperature sensor monitor with a built-in local temperature sensor. Okay. All right. So power coming in on, it looks like 1 and 10, but I think 10 was not connected, so that's fine. Okay, and then 2 and 3 have a built-in thermal transistor diode. I guess on this end, capacitor, resistor, and built-in diode, processor or ACIC. Or ASIC. But it says built-in, so I'm curious if that's actually built into this package right here. And then 4 over temperature shutdown, thermal over temperature shutdown. So if this gets too hot, I guess it turns itself off, and then this part actually communicates with the ESM bus controller. Clock, data lines. This looks pretty simple. Nope, don't really care about dictation. Thermal shutdown or fan control pin, open drain requires a pull-up resistor. So it's not randomly shutting itself out. So I wonder if it's something to do. Oh my gosh, I'm sorry. I'm really, really sorry. Okay, I didn't really sleep well at all last night, so I might just pass out after this one. Okay, let's check and see exactly what's going on here again. Alright, so this is low, and it looks like Thunderbolt thermal sensor alert T low. So when this is low, this is sending the alert, if I had to guess. I'm gonna do some diode measurements. It's probably gonna be weird just because we actually have this component soldered on, not on another one. So let's see. 0.55, 0.52, 0.53, 51, 52, 53, or 55, 52, 53. Six 6.3, 5.8, 5.8. That one is OL 0.8, 0.3. That one is 0.5, 0.6, 0.3. Now, the difference is that we still have this connected. I'm probably about to pull this off, undo everything I just did. Yeah. Why not? I'm at the point of just passing out. We'll check and see. Get some diode measurements underneath and see what happens. Alright, I'm going to give myself a time limit. I'm going to go till 3 o'clock. It's 30 minutes from now. And if I can't make any progress with this thermal sensor, I'm going to turn this into a part 2 live stream. We fixed the SSD issue, I believe, but in order for us to figure out, we have to fix this thermal sensor issue. Now, the thermal sensor issue was brought up after the fact, or after the SSD quit reading because of that hole that was in the board. So we actually wouldn't be dealing with this right now. But no use of crying over spilt milk. People don't make mistakes. They make happy accidents. I'm just ready to go to bed. Okay, good to see that my traces actually held up. Alright, let's go back for these measurements again. Alright, so 0.54, 0.54, 0.62, ground. Point 0.58, 0.58, 0.63, ground. So about a 0.4 difference. Not really big enough for it to be the issue. Let's check here. .28 OL ground OL 0.28 OL ground OL. .31 0.8 ground OL. Alright, so I'm getting 0.8 here. Let me compare that again because I have seen my probes kind of troll me this evening. Because I think we were just getting OL right here. Yep, looks like this is our issue. Alright, why? Why are you our issue? What could possibly be different on this one? Test again, just to make sure we're not crazy. Yep, 0.8. Goes all the way here to this capacitor. Alright, well, I think we found kind of an issue as to why our thermal sensor is not working. We're getting a weird diode reading. And it has to do specifically with this pin. Did we not solder on correctly? Nope. That capacitor looks perfectly fine. Alright, back to the board view again. Pin 4 is actually fine. At least that I'm aware of. It is an OL, so it is kind of hard to troubleshoot. Okay, where else do you go? So somehow there is a connection between that and UB800, which if I remember correctly, that's a CD3215. And it just looks like it's ground. It might not be, but it looks like it is. It's not. It looks like this might be our Thunderbolt. This might be our Thunderbolt IC. Okay. Where else does he go? It just kind of goes under the ground. Okay. Is the capacitance of this capacitor wrong? Over here it says that it's 2200 picofarads. Let's put our multimeter into capacitance and see what's up. I'm getting 41 microfarads. Let me make sure I did that right. Okay, I'm getting very small. We're getting in the nanofarads, or farads. Kind of the same deal here. So the capacitor is fine. So why would we be getting a different diode reading on here if the only other place that it connects to is going to be UB800 or UB1000? Alpine Ridge. Okay, and what is this? USB-C high speed C1. Is that going to be our what is the word that I'm looking for? Is that going to be our USB controller? Let's find out. It looks like it's underneath cowling. Alright, cowling. Wrong one. Alright, this is the cowling that we need to move? I don't even know if they call them cowlings on here. I just know they call them cowlings on the iPhones. Not seeing anything obviously wrong here. Okay. Still confused. Does that mean that there's actually a via underneath there? That's supposed to go all the way to our Thunderbolt controller. How else does it talk to it? So this one is over here anyways. That's the only other thing I could think of is maybe when they ripped off the components, if there's a via, because there's got to be some way that this connects all the way to the Thunderbolt controller. And it's in a horrible spot too. Somehow these got severed from each other. Oh man, alright. So that looks to be the next thing. Somehow. The thing is, it didn't look like underneath here there was a via. Now then again, what probably is going on, if we were to completely remove this from the equation, there's some sort of connection underneath. I don't know. I want to say, yeah, there is some sort of connection right here. Like a via of some sort. The only way for us to figure out is we would actually have to remove the resin that I had put on there. I guess really the only way to try to figure out is if I can probe them together and see if there's some sort of continuity. Well, there's not. No, we've already confirmed that there isn't any. Okay. We have some vias hiding. Now we just need to figure out where that via is. Man, this got a lot harder. Oh, Okay. These are relatively easy to put back. I am going to need a new razor blade because I did ruin my scalpel whenever I was digging through the board to try to fix the trace for the SSD. So let's see if we can kind of expose if there's a via. It would only make sense that there'd be a damaged via underneath the missing U5860 and not underneath those capacitors. So, why aren't you popping off? Alright, so let's grab another scalpel. I know this last hour has been kind of dull. I'm looking forward to see if this computer is even going to turn on, but it looks like we still have more thermal issues we have to address. Surprisingly, we fixed our pin 4. But we haven't fixed pin 2. Okay, let's start digging. I feel like that's all I've been doing on this board, is just digging away. There's something under there. Question is that ground? It looks like a trace. That doesn't look like ground. Let's find out. Are you gonna beep when we put you in continuity? Please don't be ground. You're ground. That's not it. I'm starting to lose it. I don't know on this one. So there's not a via on this side. Which means we're just gonna have to end up covering this back up. I'll just make it a little bit larger. That way I can go ahead and fill it back in. But honestly, I think that's a night. I think I'm going to go ahead and stop right here, because now we need to figure out why the thermal sensor is not working and why we are getting different diode readings. So I think that's it. Alright, well, in my time it is 2:47 a.m. I stayed up till 4:30 last night taking care of some more boards. Only slept for about 3.5 hours. I'm actively falling asleep on this repair, but we've made some progress. We found a hole. Very interesting. Never seen anything like it before in person. And we dug through the hole and found that there was a severed trace that sends some sort of signal to our U9400. U9400 is what's actually going to send a signal to the PMIC to generate the 2.7 volts needed for turning on our SSD. We're getting power now. Excuse me. The SSD looks like it's actually turning on. Downside now is there is a thermal issue. Thermal issue is something that happened after the fact, and I'm trying to troubleshoot pretty much at this point. What can we do to get the thermal sensor working again? Doing diode mode right now, and we notice that there's a one specific pin, pin 2, is getting a weird diode reading. It's actually saying it's OL, which isn't true, because it looks like somewhere there's a trace that is going underneath the board all the way to UB000. Now, it looks like maybe that trace is on the bottom side over here, and it's running underneath the board where it finally makes its way to UB000. We may have to check and see if there are more severed lines, but being that that is completely gone, since there's some sort of disconnect, we're just getting an OL. Just OL instead of what we're getting a reading on our other computers. So this has been a fun one. It's been going on for 5.5 hours. Admittedly, this is one of my longest streams I've ever done because this is not a normal repair. This is also why we charge a flat rate for board repair. Sometimes a board can take 5 minutes. Sometimes we run to a situation like this where, you know, this is 5.5 hours into a repair, but I'm going to have to take a nap, kind of rest up on this one, come back and check on it in the morning and with some new fresh eyes and see exactly what's going on. Anyways, I appreciate you all spending your evening with me. It's been fun, and if there's a sorry, went into customer service mode. If you have any questions, comments, leave them in the comment section below. I'll see you guys in the next one. Have a good night or morning, depending on where you're at. Bye.